So then we can actually discuss some questions.
Hi Vicky, can I speak with you?
Yeah, sure.
Actually, I was unable to watch the videos, part of the videos till matrices I have.
Okay.
I'm not aware of what is this algorithms and everything. So are you going to take up any questions regarding those algorithms and teach today?
Yes. So don't worry, even if you haven't seen the lecture, it's okay. I
No,
think
I
I'll
have seen
discuss
part
those
of lectures.
concepts first.
Yeah.
It's okay. I'll discuss those concepts and then I'll take up the
I was
questions.
not well, so I could not.
No problem. No problem.
Any questions regarding this this Belford
Bellman-Ford.
Bellman-Ford algorithm? And
There is actually what I have done is like I have questions for all the things like, but
each
firstly I'll
algorithm.
be discussing this Dijkstra. I think you would have gone through that. Dijkstra? No, you would have not gone through it because since you are doing this matrix thing still, right? So
Yes.
maybe I will discuss this Dijkstra algorithm, and then what I could see from the previous instructors that this was pending, like Dijkstra and
Yes, Dijkstra was not taken
right,
taken up,
right.
but the other one, Bellman-Ford,
Oh, okay. So you have doubt in that?
Floyd, those two
Floyd-Warshall.
algorithms.
Okay.
Yeah, because in the lectures, I, I don't think so. It is much explained.
Okay. All right. So maybe we can take up that as well. So first
One
priority we'll give
question
to.
regarding to each algorithm.
Sure. We can do that
That will
way.
be helpful. Thanks a lot.
Yeah, sure. We can do that way. Yeah.
Thank you.
Okay. So let's wait for like only 50% of you have joined. So I want all of you to join here.
So I have a question.
Yeah.
Is there any session for the enter?
You mean
Session?
revision session?
Yeah.
Yes, we will have.
Okay, before 3 we will have.
Yeah, we will have. Definitely we'll have.
Okay, because in calendar it is not updated. That's why I asked.
Yeah, that is, those dates are yet to be decided. I mean, we are yet to decide that. So we'll decide and then we'll let you know.
Okay, that's.
Yeah.
And yes.
And also we'll try to keep a mock for you. So
Okay.
you can give a practice to that as well.
Okay. And one more thing that week 10 grade assignment solution still I think it is not uploaded.
Oh, is it? Okay,
Yeah,
then
maybe.
we'll make sure that it happens now. So maybe I'll just ping them up once. They'll do it right now.
So around when will be the mock test?
I see your exams are on 3rd, right?
Yes, sir.
Yeah. So maybe like very soon because now you don't have much time, right? So it's like 6 plus like hardly 10 days or something, right?
Yes, sir.
Right. So even you need to rush and even we will have to rush. So what we'll do is maybe like we'll provide it soon. So it's Thursday, right? So maybe we can keep it on Sunday or some days like Monday or Tuesday. But I think this is something we'll discuss after this session. I will discuss with our team once.
Sure,
Most
sir.
likely on Sunday because all of you will be available. Or like if any other day, then we'll try to keep it in the late night so that all of you can attend that.
Sure,
Okay?
sir. Sure, sir.
Yeah, and live session probably it will be next week. So
Sir, I have a one doubt in activity question.
of which week 11?
Yes, sir. Week 11, 11 point activity 11.2 question number 2.
Okay, what is that? Okay, let me just open that. But shall we take that at the end?
Okay.
Will that do? So that everybody will be on the same page. But surely I will take you through that page. Okay.
So one
Okay,
general
sir.
doubt that in the revision session we will be having a revision of the whole one week 1 to 12. I mean 1 week to 11.
Yeah, so that's what it will be because you see this is end term. So the equal weightage are given for not equal weightage, but yeah, we have tried to cover. We have tried to touch upon every week. So of course, then we'll have to discuss all these week contents, but not in great details, but whatever is needed in your examination point of view. So we'll try to discuss in that sense, and even you can orient your studies in that way. right?
Okay, yes, sir. So one thing is because what happened, I guess there was a previous session yesterday about Maths 1, and many of us didn't have that notification about that we are having a session of week 1 to 6, some kind of revision session or something
Oh,
like.
that was not week 1 to 6. It was my session only, but it was diploma session. So it was for diploma direct entry
Oh,
students.
okay, okay,
Yeah, so
okay,
that is different.
okay.
Yeah,
Thank
and
you,
they
sir.
had entire syllabus, in fact. I mean, week 1 to 11. So that's nothing to do with our regular thing, what's happening here. Those are for those students who are directly up enrolling for an diploma.
Okay, so that's why we got confused, some of
No,
us.
don't have to.
Okay, thank you, sir.
Yeah.
So the weightage for the what is it, from week 1 to 6 and 7 to 11, it is decided or it will be decided?
Actually, we have made the paper already, and we thought like we'll formally announce something. Like we haven't even like discussed like, okay, what is the weightage? Because like when we create questions, it's more like we try to intermix the questions, right? So
Mhm.
then we have to segregate accordingly and then inform you. So if I can recollect and tell you, like I told before also, so you can see that from week 7, 8, 9, 10, 11 up to this, like 7, 8, 9, 10, 11, you have weightage of 60%, and week 1 to 6 you will have 40% weightage.
Okay.
I can just roughly tell like this is what, but of course we'll tell you in detail like how you can plan your strategies for your preparation, maybe in the live sessions, in the further live session. Like mostly it's a revision session then, so we can tell you accordingly. All right. So yeah, so let's start our session, because I guess you have session of CT, I guess, because
Yes,
it
sir.
was earlier, it
7.
was coinciding. So we will try to finish by within 2 hours, and then you can see. So yes,
It's
so
from 7 to 9.
yeah, so 7 to 9, but you wanted 1 hour of break, right? And I'm pretty sure it's not going to last for 2 hours. So
No,
it's the normal promise we make. Okay, we'll do it in 2 hours, but let's see how far it goes. But certainly we'll try to finish it as early as possible. Okay.
Can you say which weeks are weightage of 60%?
Okay. So
7 to 11.
calculus, so it's like calculus plus graph theory. You can count it as 60% weightage.
The last few weeks. Okay.
Yeah,
The last
and
5.
yeah, so the last, it's basically your quiz. You cannot say quiz 2, but calculus from 7, 8, 9, 10, 11, 12. Yeah, like that.
Will the revision be as good as how week quiz 2 was
I
done?
get it what you are asking, but yeah, we'll certainly try to keep something similar to that. And
The
yeah,
quiz 2 was really good. The revision what Srikanth has done.
yeah, right. So we'll try to keep it in a similar manner. So let's do it. Maybe we can just discuss that as well, how to be done. And
Yeah, that'll be helpful.
yeah, all right. So this is what for today's session. So we are going to discuss some of the questions on week 11. So myself, Vicky Kumar Sharma, I'm maths course instructor. So it's like normal formal thing. By now you all of us are familiar. Even I know you, even know you know me, and you also know how does this session go. So I don't really have to explain all this. But I can see 66 of you are here, but not all of you have been actually joined this periodic. So it's better that you join and participate. Otherwise, it'll become boring. If you participate, then it will be good, so that it can be interaction and then we can learn together, right? So here it's just a test problem. How confident are you with respect to maths 1 content? So you will see like 3 options popping out. So let's see, like it's just to familiarize you with how this peer day goes, and I think you are very much familiar now, but it's just I want to know like how is your preparation level. Okay, so let's see. I don't know why all of you are not responding, and I don't know why you are not participating here. You should actually. okay, very confident to get GPA of 9 and above. So at least 2 of you are telling this. That's good. Need to revise to build up the confidence. Not at all confidence. 3. Okay, so most of you, but I'm happy for those who are telling can score 9 and above. That's really good. Not at all confident. Maybe like as you do, you revise, and then I think your confidence will again boost. So that's what on general. So all right. So just a quick question, and I assume like you have gone through the previous live session and you have gone through the content. So it's just a quick question. Okay, so first question here. To find the shortest path from a fixed source vertex to every other vertex in a graph G with no negative edge weights, which algorithm should you use?
So Dijkstra.
Dijkstra's.
Yeah, just
Right.
extras algorithm.
Okay. All right. So yeah, that
Dijkstra and Bellman, we can use two methods.
So Dijkstra algorithm. So what about to find the shortest path from a fixed source vertex to every other vertex? So
Bellman.
again, you read this again. To find the shortest path from a fixed source vertex to every other vertex in a graph G with or without negative edge weights, and there should be no negative cycle. Algorithm.
Bellman-Ford algorithm.
Can you use Floyd-Warshall saying that all the vertices are reachable from every other vertex? Yeah, so here the actual answer should be Bellman-Ford. Okay, so all pair shortest path. Which one? For third. If you find out all pair shortest path.
Floyd-Warshall algorithm.
Floyd-Warshall, right. And what about this MCST? It's a minimum cost spanning tree. Which algorithm should you use?
So Prim's
And
Prim's
Kruskal.
or yeah, you can use
Kruskal.
Algorithm. Kruskal.
Yeah. So yes.
Excuse
So
me,
you
sir.
can- yes.
Sir, for the first one, we can't use Bellman-Ford, right?
You can still use. But essentially what we do is, since we just wanted to highlight that these things, you see, no negative edge weight.
Yeah,
so you
yeah.
can actually use. Yes, you can actually use.
Yes.
All right. So yes, as you told, it's a Floyd-Warshall algorithm for all pair shortest path, and for MCST you can use either Prim's or Kruskal's algorithm. So all right. So that is about that. So as it was told, that we will be discussing here Dijkstra algorithm, then we'll be discussing about MCST, minimum cost spanning tree, then followed by we'll be discussing some questions, or like maybe I can brush up the things such as Floyd-Warshall, Bellman-Ford, and yeah, these concepts. And then we can see, maybe I can take up some questions on that and then discuss it here. Some different questions from what you have. So how do you do this? So as you told, Dijkstra algorithm is used to find the shortest path from a fixed source vertex to every other vertex in a graph, right? So what are some facts that you should keep it in your mind to identify Dijkstra, or like when you can use this algorithm? So it is applicable for weighted graphs with positive weightage. So there should not be negative edge weights. Okay. So this is some facts that you should know. So what is the algorithm for using this? So if you would have gone through the lecture, so, or like I don't know, in the previous session it was not discussed. So what you do here is, you start with the source vertex. This is something it will be given in the question. Okay. So let's say the source vertex is I. Then what you do is you initialize the value for the source vertex, that is your I, to 0, and every other vertex of the graph to infinity. So essentially what you say is, the distance between the source vertex to any other is infinity. Basically, you haven't explored that, or you haven't reached that. So you say it's infinity. So that is what initialization is. Then what do you do? The next step is you update the distance values of the neighboring vertices of the vertex I. So all that vertex, all that vertices which shares an edge with vertex I. So you find the minimum distance, and then you update that minimum distance value to its neighbor. This is what you do. Okay, so this is very wordy. So let's take up an example and then understand this. How does it happen? And I don't know, like if you have gone through the lecture, if you are already aware of it, like how it is done. then I think you will be able to answer this. See, an undirected weighted graph G is shown here. So you have to find out the set of all positive integer value of x such that if we use the Dijkstra algorithm, the length of the shortest path from the vertex A to vertex J is less than 13. Okay, so which among these is the correct option? That is something you have to choose. So you have to find the set of all positive integer values of x such that if you use the Dijkstra algorithm, the length of the shortest path from the vertex A to vertex J is less than 13. Okay, so if you don't know how to solve this, so you can wait. I'll explain you how does it happen, or you can just try with whatever knowledge you have. I assume you should know by now, but there are some who doesn't know this. So you can take 2 minutes or maybe 3 minutes, and then we can discuss this. I got some 10 responses now. But not all of you have joined. If you want to join here, go to joinpd.com and use this code, what you see here on the top right corner. It's written KIMGHK.
Excuse me, sir.
Yes.
Sir, some silly question actually.
Okay.
Sir, like for this algorithm, Dijkstra's algorithm,
Okay.
can't be used in a way like for the all pairs, like suppose first we fixed vertex A and then find all distance from the vertex A.
Yes.
Then we fixed vertex D, and similarly we fixed each vertex each time and then find distance.
And then you get what?
And then we can compare like which distance came out to be minimum from which vertex. Can't be used like that way.
But why do you want to do that?
No, like all in all pair questions, in all pair sort pairs, we use different algorithm.
Floyd-Warshall.
We use different algorithm.
Right.
So can't we use this algorithm in that way?
You can use it. You can change the source vertex and find out the nearest shortest path. That is also doable. You can do it. But you see, Floyd-Warshall is essentially will be doing the same thing, like what you are telling. In Floyd-Warshall, I don't know why it looks very complex, but it is not very complex. Maybe we can discuss some question here and then we can understand that it's not really difficult. See, and essentially what you are telling is changing the, source vertex and finding the minimum shortest path. Essentially, you are doing Floyd-Warshall only. So what you will do is
Floyd-Warshall is modified actually.
Right, it's more formalized, you can say, but essentially what you are doing is same thing as Floyd-Warshall. Maybe see, one way of doing is like formally teaching something, right? So like what professor has taught you is like very formal thing, right? So when we do it on the pen and paper, it goes like in a very informal way. So when we do it in that way, then you will understand, oh, it's essentially, it's actually, you will understand that it's kind of easy. It's not that difficult. So maybe we can just discuss that here, and you will realize that it's the same thing what you are telling right now.
Yeah. Okay.
Yeah.
Thank you,
Yeah.
sir.
Yeah. So, okay, so we can discuss this right now. Okay. So do you need any of you, do you need any time, any more time?
No, sir.
No,
Okay.
just half a minute.
Half a minute. Okay.
See, sir.
Yes.
Sir, I had a doubt. Maybe I can discuss in the end of the session. Week 10.
Yeah, we can do that. We can do that.
Yes.
So we can proceed.
Can proceed. All right. So let's see what are the popular answers. So most of you are telling B and followed by A. So let's see what is the popular answers. Okay, so the popular answer is B. Let's see how it happens. So would anybody like to discuss this? If yes, raise your hand here. Okay, Rishabh.
Yes, sir.
Yeah, Rishabh. Tell me what should be your
Sir,
strategy?
yeah, my strategy is, since it's given in the question that the minimum shortest distance, it could be less than 13.
Mhm.
So what I do is I let X be X. So I go from A to B, B to C, B to E actually. So 2 plus X. And then I go to C to E to G, which is one more. So 3 plus X. And then G to H, 2, 1, we add 2 more. So 5 plus X, and then H to J. So 6 plus X, which this distance should be less than 13. So X must be less than 7.
Okay.
So in option B, we can see that in the set 1, 2, 3, 4, 5, 6, it
Yes.
could be because the X should be less than 7.
Yes, you're right. So yes, Rishabh, that is the right way of doing this. So thanks, Rishabh. Maybe I can discuss this now here. So what you told is definitely right. All right. So when you're doing this Dijkstra problem, right? So what is the first thing that you have to do is, you see this whenever this X thing comes into the picture, just imagine this X is not there. Now what Rishabh did is, that is completely follow that. That is also doable. I think most of you will do what Rishabh has done, and also most of you will even do this. So there is a 50-50 thing. So what you could do is, you can just think that there is no edge between BE. Okay. So what you do is, you basically remove this edge BE from the graph and find the shortest path from vertex A to every other vertex, to every other vertices using the Dijkstra algorithm. So you basically start with vertex X, and you know the algorithm, whichever is your source vertex, you initialize that to 0, and rest other you give it to infinity. You say that's infinity, right? So there's something like this. So you see on the top of each vertex, this distance is shown here. So you can see, since A is the source vertex, it's given 0, and rest other vertices, they have assigned a value infinity. Now what we assume, that there is no X there, right? So there is no BE edge, right? So what then? So now which vertex should you choose? Which vertex will you go to? Which vertex maybe the next thing you should go?
C. No,
So
B.
So okay. So let's see this. So the shortest path you will find to the nearest vertices. So basically what you do, what was the next step in your Dijkstra algorithm? You will update the minimum distance to the neighbors of the source vertex. So what are the neighbors of the source vertex? B and D, right? Right. So you will update the nearest value, you will update the minimum value for this. Since infinity is very big number and 1 is a small number, so of course the vertex D gets the number 1, right? So the distance between A and D is assigned as 1. And similarly, the distance between A and B is assigned as 2, right? You can see there on the right hand side of vertex B, it's written 2. So basically we have assigned the minimum distance value, right? So what you are doing is, essentially, you started with your source vertex, and then you see what are the neighbors by when I say neighbors, it means the adjacent vertices, like which the other vertices which shares the edge with it, right? So those vertices will be given a minimum distance value, right? Since infinity is a very big number, so that cannot be a minimum value. Therefore, the 2 is being given for B, and you see the distance of D, vertex D from A is 1, right? So now which vertex should you choose from here? Whichever is the minimum. Now the minimum is again D. So what you do is you start moving from D, where all you can go. So you can go to B and you can go to, but A, since you don't have to really go to A. So now you will say for vertex B, which is minimum, is 1 plus 5, which gives 6. 6 is minimum or 2 is minimum? 2 is minimum, right? So the next vertex is B. So that is something you do, right? Now you update the distance value for each of the vertex in the given graph with the neighbors of D, right? So now note that whenever you update the new thing, you just take the minimum values of the neighbors, right? So now the minimum value over here was 2 rather than 5. Though even though you're going from D to B, but the minimum value still remains the 2, right?
Can you explain once again?
Yeah, sure. So you see this. First, what did you do is you started with your source vertex. That is your A. Okay. So now what you go to your nearby neighbors. So nearby neighbors means whichever you go to those vertices which shares an edge with the source vertex. Okay. So you see the neighbors of the vertex A is B and D, right? So what you do, you actually update the distance, the minimum distance. So initially, all except A, all other vertices were at infinity, right? So infinity is a big number. So what, now you're going from A to D and you're going from A to B, right? And then you update the minimum distance, right? So when you go to A to D, the minimum distance turns out to be 1, right?
How did we
so that
get
value
1?
is, sorry?
How did we get 1?
Okay, so you assign this value, whatever this edge value is, that value, you assign it here.
Okay.
So, sir, in that, but that from D to B, you don't assign each value, right?
Sorry. So when you go to from D to B, then it will be 5 plus 1, whatever the value is given for D.
Then
Essentially, what it means is when you go
6.
from, so what you do is from source vertex, if you're going to D in this direction, that is A to D to B, then what is the weight? What is the, let's say this is length, then what is the length for this?
6.
It's going to be 6, right? So it will be 1 plus 5, which is going to be 6. But you can go to B from your source vertex itself, and the minimum distance you find is 2. So you will not upgrade this value to 6, rather you will choose the minimum value, right?
Yes.
Okay, so that's what we do. So now we are done with here. Now from B we'll go to the other vertex, that is your C, right? So now what will be the minimum value for C then? Will it be 6 or infinity?
6.
6, right?
6.
Now you can ask that, yeah, we could have even gone through this, but when you come from this direction, you find that it's not the minimum distance, right? It's actually greater than 2. So you don't choose that. You actually go with 2. So now from 2 to 4, so C, the distance from source vertex A to C is actually how much? 6.
Yes, 6.
So now 6. Okay. Now from C, you can go to H, you can go to E, right? So now you will update the minimum value because these are the two neighbors of C. Even B is the neighbor, but since you have already explored this, or you have traced that path of the vertex B, so you will not be going through this, but now you'll be going to H and C. So now you'll update the distance for this. Now could you tell me what will be the distance of E?
It's 9.
It's going to be 9. And also what is the distance of H? It's going to be 6 plus 8.
14.
That's going to be 14. So
14.
unmute all. So we'll upgrade that value. So what we do is we upgrade the value for H, vertex H as 14 and for vertex E as 9. So, but again, like when you're going to H from any other side and whichever is minimum, you'll upgrade the minimum. Like let's say if I go through this way and then I find that in order to reach H, I can go actually through this way and the distance is actually minimum. So you can upgrade the minimum value. That is totally allowed. Okay. So now, as if now, let's upgrade this value. So it's going to be 3. So 6 plus 3 is 9. Essentially, we should have even done it here and shown that value as 6 plus 8, which is 14, which is, it's okay if it is not done, because what we have done is we have chosen the minimum value. That is also we can do. Okay. So now from 9, you can go from E, you can actually go to G and you can go to F, right? So now which is the minimum distance? 9 plus 1, which makes it 10, 9 plus 6, which makes it 15, right? So of course, over here, this value should have been 15, but why are we not giving this value here is, like, as per the algorithm, we should give a value, but since we are, like, since that is again a larger value compared to this, that is why we are not upgrading it. But you can give a practice like that, giving and assigning some values to it. Okay. So now from E to G, you have gone and you found that the minimum distance is 10. Now from G, where all you can go? You can go to H, you can go to F, right? So now you see this, what is the minimum distance? So from G, if you go to H, it turns out to be 12. And from G to F, it turns out to be 12 again. So actually you can give that, you can again assign the value here. So you see this, both of them gets the 12 value. See, why we did not give it at that point of time 15 was because, intuitively we knew that, okay, there will be some other shortest value. That is why this value was not upgraded. But actually in practice, you should do that. You should upgrade the value as 15 earlier, and then you should have gone. Okay. So now we have and over here 6 plus 8 was making how much? 6 plus 8 was giving it 14. That's why you can give a practice, but when it was 14 and 10 plus 2 was giving you 12, you would have actually gone with 12 as the value, right? So that is one thing. Now from H, I can go to I and I can go to J. Now whatever I'll get the value, that is certainly going to be the minimum, right? Because 12 plus 1 here, it makes it 13, and even there it makes it 13. That is at J. So now you see that from source vertex to every other vertex, we have found the shortest path, right? So now, just a minute.
So I have a question.
Okay. So did anybody ask some question?
Yes, sir. Sir, for F, it is supposed to be 15, right?
For F, it is supposed to be 15. No, you see, when you go from, that's what I was telling. You can actually go from E when you're going, you can actually explore its neighbors such as G and F. So it turns out to be 15. But once you go to G and then you come back to H, you see the minimum value is 12.
But
right?
sir, so sir, you're telling that from when we practice, when we practice from EA to F, when we go there, we should update it at 15 first, and then when we'll come, we can then update it to 12.
Yes, you can do that. But if you practice more, you will actually not do that. You will actually take
But
the.
sir, if we update it 15, then will we think that it is already explored?
No. But again, you will always have to see it in that way that, yeah. So that is one thing, that what you told is right. But again, you will choose the minimum one. You just imagine, you just think of that problem what sir explains it. That pipe and and the fire problem. So it's just the same thing. You can just think it in that similar way, right? That is why you actually don't upgrade. We do not tell to upgrade, but actually the algorithm is like that. So we wanted to tell you that yes, algorithm is like this, so you follow that algorithm, right? But again, like, since you can go from G to these vertices, so you will explore these vertices again and you will see whichever is minimum.
Okay.
See, for example, you are at B, okay, and now you say, like, I want to go to the source vertex, okay. So from B, if you go back, so what will be the minimum distance to reach your A? It is going to be more than 0, right? So you will not upgrade it. So if you follow the algorithm as well, you don't have any problem. That certainly works. Okay.
So it is not necessary to number F, right? Because we have to go to J. So we can skip it, right?
You can actually do that. But here we were just finding out the minimum distance to every other vertices. That is why we did this.
Okay.
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 Okay. So now you say this. This is the
Sir,
path you have to follow. Yes.
sir, in this question, why we cannot take the path from is it C? When we reach the 9 and 9 to go to, we take a 1 and reach the 10.
But tell me in terms of vertex, which vertex?
So I cannot see very well.
Okay, you cannot see the thing. Can you
Yes,
see now?
C, so C.
C, is it? Okay. So in from C,
Why
what
we
you are
cannot
telling?
go from C to H?
C to
Every
H.
time we take the small distance.
Like
So we
see,
take to C to G is 1. So I take the C to G 1. Going through the C, G, H.
C, G. See, it's not G basically. It's E. C to E. So you go with C to E. It's because it get burnt much earlier. That is why you choose this. But essentially, what you should do is you will upgrade the value of H to 14. Okay, you should actually upgrade that value to 14 and then again explore that.
I understand. We C to G is reaching fast, burn fast, then compared to H.
Right.
Okay,
Right.
sir.
Like
Clear.
that. Yeah.
Thank you, sir.
Welcome. So all right. So now you see this.
Excuse me, sir.
Mhm.
We can go even to the I, right? H to J, of that H to I.
Sorry, what? You can go to IES.
I mean, in the order, like after passing through G and H, then you have taken the J. Instead of J, we take the I. It would remain same, right?
Yeah. So basically, what it means is this shows the distance to reach these vertices, right? So it doesn't matter like which you are going to. You can go to both. You actually have to go to both, and you have to upgrade the minimum value. But what it was asked in the question was the distance between A and J. A to J was given as 13. Right.
Okay.
So essentially that is why we were giving more emphasis to J, but you can go to, but here what it shows is the shortest path from the vertices X. So we have covered all these vertices with the shortest distance. Okay. So that is something we have done. Yes. But when you're going to J from A to J, so you see this is the one shown in the green color is the path that you have to follow, right? Because you choose the minimum values, right? So you see that from A to B, you actually choose this path rather than going through D and B. It's just because you know that when you go from D to B, you have to choose this distance, right?
Right. Sir. Yeah.
So it will be 6, right? Right. So that is, this is the path you have to follow. But now you see this is not the shortest path because in the question it says the distance has to be minimum, right? So now comes the next thing. Let's say now this comes X. Now you see this to reach the vertex C, the shortest distance is what? The shortest distance is going to be 6, right? From A to C. Now from C to, sorry, 1 minute. Yeah. So when you're going from B to C and then see when you're going to E, the one which is shown in the green, you see when you're going from B to C, B to E. I don't know if you can see this image. I'll just zoom this image. So you see this when you're going from B to B to E, following this green path, what is the distance you are covering? You're actually going through this, right? So it's 4 plus 3, right? This distance you are taking, right? Right. So essentially this path, if there was an edge earlier, right? So if this B is there, so this distance actually has to be lesser than this 7, right? Because this is the only path I can go if this was not there, right? So I have to make sure that this X is lesser than this 7, right? As Rishabh was telling it. So the same thing, you have to make sure that it is lesser than 7. So if it is lesser than 7, then what are the values it can take? It can take 1, 2, 3, 4, 5, 6. Right? So that is what it is. Yes. So now you must be wondering, then why did we even did all this path thing? Why can't we just essentially tell it, okay, if this is 4 and this is 3, just take it in this way? Because you didn't know this, which is this green path. We first had to identify which is that green path. it could have been like this as well, right? You could have gone through A, B, C, H, I, right? We could have claimed that, okay, this is the shortest path, but actually this is not the shortest path, right? It's this green color path is the shortest path, isn't it? That is why we first had to identify which is the shortest path. After identifying the shortest path, we came to an understanding that when I have to go from B to E, I have to necessarily go through this green path, right? And this green path is 4 plus 3, 7. So essentially this, when I go from B to E, then I have to make sure that this X value is lesser than 7. That is why we did all that. Okay. Somewhat clear, is it?
Yes.
Yes.
So, sir, why it need to be lesser than 7? I don't understand that part.
Okay, so that's here. I'll tell you again. You see this, why it has to be lesser than 7 is, what are we doing here is, look at this green path.
Oh, okay, yeah. It is minimum distance from 4 plus 3.
Right. So what are you doing here is, you are going from A to J following this green path, right? So now following this green path, if you want to go to B to E, earlier what you are doing, you are going through C, right? So when you go from B, C and E, what is the distance you are taking? 4 plus 3, 7, right? So we have to make sure, if I want to go to B to E, then I have to make sure that it is lesser than 7.
Yes,
Understood? Yeah. So yes, this is how you will be able to find out. See, maybe I took a longer time to explain this, but when you practice this, you'll get used to it and you'll do it in a lesser time. Okay. So give a practice to these kind of questions. So I have one more question on Dijkstra. So it's basically the same thing. Yes.
Sir, I just want to ask, in the option, can you show me
options?
Yes, sir.
Yeah,
Sir,
this was the options.
Sir, if in these options the 1 to 6 all our options are correct, but can it also be possible that the options such as 2, 4, 5, which is not the sequence?
2, 4, 5, yeah, even that is, I mean, that is also correct. But look at this here. Find the set of all positive integer values of X. So we are telling all positive integer value. You could have actually given as just one as the option, and we could have told this. But
So
since we are asking,
can we find X value as 1?
Can you find in the sense what you
find X equals to 1 means X has the value 1?
You can tell that it can have any values in 1 to 6.
So what could be the path of it if X equals to 1?
So the path would be A, B,
7.
E,
7.
So you mean to say, like, so how you will be going is, you'll be going through
yes, sir,
A,
yes, sir.
B, E, G, H, J. That time the path changes this way.
So but the value could be different, then the value could be different.
The value will be different. That is what it's been told here. The length of the shortest path from vertex A to J is less than 13.
Oh, means the length of the total path can be 6, 7, 8, 9, 10, any of the value.
No, see here. Yeah, the total length, right?
Yes, sir. Yes, sir.
Yes. But it will be lesser than 13. Yes.
Oh, okay, sir. Thank you.
Yeah.
Sir, here
I
this
have one
number,
doubt.
Sir, here these numbers, what does it represent? Like, what I actually calculated the correctly, but what the 1, 2, 3, 4, 5, 6. No, I thought these numbers has to be there in the lines.
No,
So
this
what
indicates the X values.
X
See
value.
here in the question, no, find the set of all positive integer values of X such that if we use the Dijkstra algorithm, the length of the shortest path from vertex A to vertex J is less than 13. So this indicates X values.
Option A is also correct, no, sir?
See, but it does not contain set of all positive integer value. When this all was not there, then yes, you could have done. But since we are asking all, right? I hope
I have one doubt. I have one doubt. If this green path, if the count is, if it is 10, what will happen? And if it is 15, what will happen to the answer?
Where 10 you are telling?
The green path, we identified the green path, right? A, B,
Okay.
C. If this count came as 10, in that case, what will be our answer?
4 plus 3 here. Instead of this 4 plus 3, it's like 5
We got
plus
13,
sorry,
right? Yeah, we got 13, right? Count shortest path.
Okay, like when you're not going through this path,
Not with X. A, B, E.
this
Yeah.
path,
Yes.
this green color path. Okay.
Green color path. I got it as 10. That case and 15 case. I want to know.
Okay. So you see this when you get it as a 10 and in the question it is being told as lesser than 13, right?
Yes.
See, that is why this question is unique in that sense, because see, when we are claiming that as 13, then we have to make sure here it is 13 and it is following the shortest path.
Okay.
If that was the case, we would have modified the questions accordingly.
Okay, fine.
Yeah, yeah. All right. So now you see this, when X is lesser than 7, then this will be your new path, right? Okay. So I hope
Sir,
this is...
it means the values can be anywhere between 1 to 6. That means it's lesser than 7. That is the meaning.
Yes.
Okay.
Yeah. Okay. So now having known this, so there is one more question on it. So basically here you can see a matrix is given. A company has branches in each of 5 cities indicated with C0 to C4. The fare in thousands of rupees for a direct flight from CI to CJ is given by the I, jth entry in the following matrix, and infinity indicates there is no direct flight. Okay. Now the question is, an employee of the company want to travel from the city C0 to C3. If she traveled by the cheapest route possible, then the total fare in rupees she paid for the flight journey was. Okay. So here there is a sample answer. If you get 10, just multiply with 1,000 and then enter the value. So what should be the thing here is you have to find the shortest path from city C0 to C3. So what you have to do is first this matrix is given. From this matrix, try to do the graph for this. Once you get the graph, then apply Dijkstra. Okay, so that should be your approach. So take another 2 minutes, try solving this. Some high response. So I could see like 90 of us are here, but only 70 of you have joined.
Sir, just a minute. I have to.
Okay. So those who haven't joined, join here and participate. It would be good. because we have so many questions. If you are not joining here and not participating, you will get bored. I mean, you should solve maths, then you will find it interesting. Do you need some more time?
Yes, sir.
Yes, sir.
No, sir.
Yes, sir. Complete.
Okay. Try doing it. You just have to do the graph and then apply Dijkstra. Okay, so shall we discuss now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so whoever want to discuss can raise your hand. Okay, Anjana.
Yes, sir.
Yeah.
So, sir, the cheapest route in this case would be C0 to C1 to C2 to C3. Because when we'll draw the graph, it would be more clear to us.
Okay,
So,
Anjana, just give me a minute. So let's first
Yeah.
see what are the popular response, and then. Okay, so most of you are telling us 60,000, 6,000, right?
Yeah.
So even you got that, Anjana, is it?
Yes, six, and multiplied by 2.
Okay. So now something like this, you would have got the graph.
Yes, sir.
Yeah. So now what, after this graph, what you are applying this Dijkstra algorithm, right?
Yes,
So
sir.
you're going from C0 to C3. So which path are you following so that now everybody can correlate what you were telling?
Yes, sir. So I'm following this path, C0 to C1, then C1 to C2, because here we have two paths, but that the path of length 3 is the shortest one.
Right.
And then from C2 to C3. Here also we have two paths, but definitely the path of length 1 is the shortest one.
Correct.
So from C0 to C3 will reach at the cost of 6,000.
Yes.
Six into 6,000 into 1,000. 6,000.
Into 10. Yeah, into 1,000. Yes.
Yes.
So good. Thank you. So yes. So the strategy was simple. Like from the given matrix, you have to draw the graph for this, and once the graph is done, you have to apply the Dijkstra, and I think you can apply the Dijkstra, right? So this is what you get. So how you were doing it? Now we came to this part, that matrix is given, we were able to draw the graph, right? Do any of you are facing problem in drawing the graph? You? Okay. So you see this from, you see what you have to do is from C0, where all you can go. You can go to C1, you can go to C4, right? So there is an edge between C0 to C2 and C0 to C4, right? C0 to C1 and C0 to C4.
Sir,
Okay.
sir, understood. Yeah.
Understood, right?
Yes,
So
sir.
just follow this pattern, you will get it. Okay. And whenever you see, whenever a matrix is given and you are asked to draw the graph, how will you orient these vertices? Like it becomes very tricky, right? Like to think whether how will this graph look like, whether it is in some circular fashion or like it's some kind of squarish or like how, right? So the safest thing to do is just make it a circular thing so that you can know you can easily draw the edges between them, right? So do it that way. All right. So now we drew the graph. Now after graph, we'll apply the Dijkstra. So you start with C0 since it is asking from C0. Your source vertex is C0 and you're going to every other vertices. Not every other, but you're finding essentially the shortest path till C3. So what you'll do, you will update the minimum value to its neighbors and you go ahead, right?
I confused here a little to take 2 or 2 plus 2, 4 from C0 to C1 because it's two-way, right?
How?
C0 to C1 is given 2 and C1 to C0 is given 2. So a little confusion for me whether to take 2 or 2 plus 2, 4. Wait.
C0 to
in the matrix.
Okay.
It's a symmetric
C0 to
matrix.
C1 is 2 and
It's a symmetric
C1
matrix.
to whether to take 2 or 2 plus 2, 4 as a weight. That's
Why
what
you
I
no you
struggled a
don't take
little.
it. You see, this is symmetric matrix, and you just have to deal with any of this triangle, like the upper triangle or the lower triangle. That will help. That will suffice the need. Okay,
Because
so
it's
you don't.
weighted graph, so I got confused whether to take 2 or 2 plus 2, 4.
No. You don't do it that way, because you see, like.
Same here.
Okay, when you got confused. Okay, so do not do that. Do not do that. Okay.
Because when it comes to 0 and 1, no issue at all. It was clear. But when it comes to the weighted graph, I confused.
Yeah. So no, even in that case, you would have had the confusion because it will be 1 plus, it will be 1 and 1. Then you could have given 2, right? If it was
Never
just
did because habituated to do with 0
right,
and 1,
I get
so
it.
never did.
No problem. But now you learned it here, right? So do not make this
Okay,
mistake
fine.
in the exam. Okay.
And sir, one more
Okay.
thing.
Yeah.
We can't go back, right? Like from C0
You
to.
can go back. Condition is you should have a minimum distance then.
Oh, like from C0 to C4, we can't go there.
C0 to C4. You can go to C0 to C4, but you have to make sure that it is a minimum distance. You can actually go, the algorithm says what? You have to go to the neighbors, right? And update the minimum values, right? So from C0, you will go to both of them, C1 and C4.
Yeah.
And you will update the values. You will update the value for C1 as 2 and for C4 as 4.
Oh, yeah. So
like that. Yeah. So you go like that. You go with the algorithm and try it. But in every time when you go to the new vertex, you make sure that the neighbors get the minimum value from that particular vertex. Okay. And then you can do it. But here, essentially, this is something we are not doing it. It's just because not going according to the algorithm is just because we just have to go through. We have to find the smallest path to reach C3, right? So there was no need to go to C4 and all that, right? So that's why we avoided that. And even in the previous example, it's just that the minimum distance, by looking at the graph, you can tell, okay, that this is the way or this is the path you have to follow. Then we did not put an extra effort of writing that other thing. Essentially, it should have been written. Okay. I hope that is okay.
Yes, sir.
All right. So now you see this. What are we doing here is we are finding the minimum distance to reach the vertex C3, right? So now you see, you can do it in any possible way. You can actually follow the algorithm and go. But what we have done here is you can go to C0 and then you can go to C1. Then from C1, you can go to C. So you see that now, I think this is based on the algorithm that C4 has been upgraded and it is given 4. Now you have to go to C2, right? Now you have to choose the minimum distance. So you can go 2 plus 3. That is going to be, so you can either go from C1 to C2, or you can go from C4 to C2. So whichever gives you minimum, you will upgrade the value. You see that 2 plus 3 makes it 5. And from here, 4 plus 5 makes it 9. So you would choose to go from C1 to C2 and you will upgrade the value 5, right? And then you have to go to C3. Again, you can go from where? You can go from C4 to C3 by upgrading the value 4 plus 10, that makes it 14. But from C2 to C3, the actual distance turns out to be much lesser than 14, which is nothing but 6. And therefore, you get that, right? So you'll be following this green path then, right, to find the shortest distance, and that's going to be shortest path, and that's going to be 6. And since it was told that it is in thousands, so what you do is you just simply multiply with 1000 and you get that 6000 as the answer. All right, so I hope this is okay.
Yes, sir.
Yes, sir.
So now to the same question, you have to answer this. If the inspection team, if the inspection team member wanted to inspect all the branches of the company starting from C0 and ending at C3, visiting each branch exactly once, then which route should he choose in order to pay the minimum fare for the flight journey? So essentially, this inspection team is going from C0 to C3, but he's making sure that he's going through all the other cities. Or in other ways, from C0, the inspection team is reaching all other vertices and reaching C3. So you have to choose the shortest path now. Okay, so that is something you have to mention now. So now you can see the sample answer, something you should mention like this.
Sir, here the ending journey will not be stop at C3, right? It will go till C4.
No. Inspection team will at the end go to C3 only, but he'll make sure that he is going through all other vertices. Maybe like he is going through C4 and then reaching C3.
Okay.
Essentially, he is covering all the vertices.
Okay.
Yeah, but he's at the end he is reaching C3.
Yes, sir. Yes, sir. Got it.
Yeah, because in earlier example, you would have seen that green color path where there was no need to go to C4, right?
Yes, sir. Yes.
But
Yes,
here
sir.
inspection team will go to C4, and then you will have to find out the shortest path. Then what will be the shortest path by covering all the vertices and reaching C3. Okay, so take a minute again. Okay, so do not put answers here in the chat window. Try to give it in the peer deck. That will be good. And if you haven't joined, join. Go to joinpd.com and use this code KIMGHK. Do not give any space and then join and give your answers there. So shall we discuss this?
Yes, sir.
Okay. So let's see what are the popular response for this. So C0, C1, C2, C4, and then C3. Okay. So make sure that you are covering all the vertices. So C0, C1, C2, C4, and C3, right? Okay. So I guess that's how it's working. And I think this is, maybe I myself will explain this. So what you do, again, from the same adjacency matrix, you draw the graph and then you get the graph like this. Then you try to explore all possible paths starting from C0 to C3, right? And how do you do this? So you start raising it this way, right? So you see, you can go it in these two possible ways, and you have to find out which is the minimum distance. So you can go to C0 to C1, and then you can go to C2, and then you can go to C4 and C3, and this would cost you how much? It will cost you 20K, right? And then if you follow this red color path, for example, when you're going from C0 to C4, and then C2, and then you go to C1, and then you come back to C3. When you follow this path would cost you 21K. So essentially this green color path is costing you less, so you'll go through this path. So inspection team will choose to go this way in order to go to city C3, from C0 by covering all other cities, right?
Sir, sir, is there any method through which we can find number of paths?
Okay,
Total
so
number
that
of
is
paths.
this question was out of curiosity. So it's not like you have any formal standard algorithm like Dijkstra or any other algorithm. This was simply we wanted to make sure that uh, it's just that, you know, some kind of what do you say, some kind of analytical thinking, that is
Oh.
something you can practice here. It's just
Oh.
that.
Oh.
Yeah, it's not like you have formal algorithm for doing this. All right, so the inspection team will choose the green color paths. Now let's discuss some of the concept of let's come to the concept of MCST. So Dijkstra,
Excuse me, sir.
yes.
Sir, yeah, sir. In this slide, sir, from C2 we had directly moved to C4. The weight of the age is 5, right?
C4, why it is 5? It should be 4, right?
Yeah, we had moved from C2 to
C2
C4.
to C4.
C2 to
five.
C4. Okay.
Yeah.
It will be 10.
C2 to C4.
Sir, we can't use C2 to C3.
You can do
So we
actually.
could use, yeah.
You can do that.
That
but
could be the minimal length.
Exactly, but this is second part of that question. What you are telling is something we did it earlier. That was something we were using the extra problem, but this question was out of curiosity. We just wanted to know if an inspection team wants to cover all the vertices and reach C3. Okay, what you are telling is perfectly right.
Okay.
That is Dijkstra. This is some part of it, just a made-up question on it. That's all. Okay.
Okay, sir. Okay, sir.
Yeah.
Thank
So
you.
this is about Dijkstra algorithm. So all you have to do is you explore the neighbors around and you update the minimum distance, and then you move to every other vertices and following the same rule. That's all. Okay. So you can practice some of the questions they are given in the grade practice assignments and also in the graded assignment. So you can graded assignment type question is something we discussed here. In practice assignment, it's given. So it's kind of simple. You can actually solve the question what sir has even done. You can try solving that question by yourself. You can do that as well. Okay. So now we are done with this. Now we'll go to this one. What is this minimum cost spanning tree, MCST? Okay. So could any one of you tell me what is a spanning tree? Anyone?
Sir, a spanning tree is a tree which we can make from connecting all the vertices with the least weightage.
That is okay. Yes, with the least weightage. Okay, even that is right.
Yeah, and the.
But what is spanning tree? But minimum thing you forget it. But what is just a spanning tree? Spanning tree, the concept doesn't.
It's nothing but DFS.
Connect all the vertices with
It is
less amount of edges.
minimal connected graph.
Yeah, minimally connected graph.
Minimally connected graph.
In a tree.
Yes, sir. It's the minimal connected.
So it's a minimally connected graph. So can I say, just a minute, I'll mute all. So you know this, let's say if I have a vertex, let's say A, B, C, D, E, F, G, okay? This vertex is there, okay? So now it's a vertex and it is well connected and you can say it's a complete graph. So I can also have a subgraph of it in which I just have A and B is connected. Is A and B a spanning tree?
No, all the vertices should be connected.
Correct. So for spanning tree, you have to make sure that all the vertices are connected. All right. So that is the condition that you have to make sure. So that's how it becomes different from a tree. That is one part of it. So spanning tree of an undirected graph G is a subgraph. That is a tree which includes all the vertices of G. See, it says all the vertices of G. So you cannot have just, n minus, so basically not less than n vertices, right? So you will have to cover all the vertices, or in other words, a minimally connected graph which covers all the vertices. Okay, so that is what a spanning tree is. Now comes minimum cost. That is different thing, but spanning tree is so much. There is no weight, nothing. It's just simply a tree which covers all the edges. Which covers all the vertices of the graph G. Okay. So then how is spanning tree different from a tree? So I just gave you an example. So if you have a vertices, if you have a graph with 5 vertices, I can have a tree, right? I can have a subgraph which is, let's say, a vertex A, B, and it is being connected, right? So that is a subgraph, and it is, you can call it as a tree as well. It's just because it is minimally connected and there is no cycle in that, right? So you can say that, but this is how this spanning tree becomes different. It's just because you have to cover all the vertices of G. All right. So having known that, what is the cost of a spanning tree? Now this comes an interesting thing. So cost of the spanning tree is basically whatever the tree you get, whatever the spanning tree you get, when you add those edges, the edge weights. So when you add those edge weights, whichever gives you the minimum edge weights, that becomes your MCST. So, or that becomes your cost, or basically, let's not say what is the minimum thing. Simply the cost is nothing but whatever the edge weights, the sum edge weights of the spanning tree is, that is the cost of that spanning tree. That's all. Then what is this? What is this MCST? So MCST is nothing but the minimum cost spanning tree. That means you might have multiple spanning trees, but whichever gives you the minimum cost weight, right? So that becomes your MCST. Then how do you actually identify MCST, right? So there are two ways for finding this MCST. One is Prim's algorithm, and another is Kruskal's algorithm. So you can get the MCST, that is minimum cost spanning tree, via both of these, like Prim's algorithm or Kruskal's algorithm. So I hope we got to know what is spanning tree. We got to know what is cost of a spanning tree. We also got to know what is a minimum cost of a spanning tree and how can we find it out. Okay, yeah, please tell me.
Actually, now whatever graph we just went through, the two questions what you have given now. So does that is spanning tree or it is not? Like if it is not, then what exactly is the significant differences from these two questions and from the definition of the spanning tree?
Which graph? The earlier graph.
Now we did two questions, no, sir? This C1, C0, C3, C4.
Okay.
Other one also. So is that a spanning tree? Like the edges are all connected and they are on.
You can say that. You can say that because those were minimally collected, right? You can say that. I mean, the green color path.
Yeah.
Exactly. But you cannot. You can say this one. You can say this as C0,
Yes.
C1, C2, C4, and C3. You can call this as MCST because this is giving you minimum.
No,
Even this is right.
Sir, first of all, this is a spanning tree, and then I can say that this is the minimum MCST.
Exactly. Yes.
Okay. And like the
you can even call this as a spanning tree, this red color thing, but this is not minimum. Right?
Okay.
Yeah, good that you recollected it from here. All right, so now let's go with some of the examples. So it's basically the same thing what I was telling you. So here you have a graph G, and see you can have multiple possible spanning trees from here, right? So all we have to do is just minimally connect it, right? It's a tree. We have to make sure it's a tree and all the vertices are connected. So you see there are three ways of getting this when you have three edges connected. All right, so now this question, it's a small question. You would have seen it in your activity also. How many spanning trees are possible for this? So as I was telling you, when you see this, you have three vertices were given and three of them were connected, and you can get a three spanning tree. So it's just that following the same way, you have to make sure it's a tree and it's minimally collected, covering all the vertices, right? So doing the same thing with that understanding, could you tell me how many spanning trees are possible for this? Just take some 30 seconds maybe.
I think 2.
Okay. So maybe you can put your response there.
In that
Hello.
Yeah. Hello.
Sorry, I missed it. I think like
Hello.
there was some poor connection or something. Yes.
Sir, can I ask you a thing? Sir, in between, till everyone is submitting the answers.
Yeah, please.
Sir, can you tell us what would be the proportion of the weeks in the final term?
Portions. You want week wise, is it?
Yeah, proportion. Yeah, or you can tell the most important weeks like this
Most
thing.
important weeks, if you
That
were to
could
ask me, I
be
would
a
say like,
great help.
okay. So this is something we thought like when we are taking the revision session, we'll let you know. But essentially for time being, you will keep it in your mind that from week 7 to 11, it has got 60% of your weightage. And from week 1 to week 6, it has got 40%. This is, I can tell you for time being. But as we are going through the thing, in the subsequent live sessions, we'll let you know that what is the weightage. Okay, so we'll let you know that. All right, so now let's go with this. And I could see like only 30 to 33 of you have given response. So let's see what are the popular response. And so this is what we are seeing, like so most of you are telling 5 to 12. But no, you are giving answers between 2 to 12. Okay, so this is incorrect basically. So could anybody like to explain this?
I'm getting 4. Is it correct? 4?
4 is, 4 is not correct.
Sir, n minus 1 is it 6 edges, 6 vertices. So
No, even that will not.
Sir,
do.
I remember the answer. I tried it. I tried this question, sir, but I was not able to solve it. So
okay,
that's why I
could
haven't.
anyone tell why? Could anyone hear?
Sir, would it be 7?
7 is incorrect.
5?
Okay, Satyam, could you tell Satyam why you are telling 16? Satyam?
Yes, 16.
Yeah, could you tell why?
Maybe I can try.
Yeah.
Yeah, so for the first one, the graph 2, 0, 1, and 3. This could be make in the 4 ways.
Correct.
And similarly, the other one we can also make in the 4 ways.
Right.
And by concluding both, we can make it in 16 ways.
Right. So the 16 is the right answer, but how? So what you told is right. So now let's say this. These are two sub graphs of it, right? So let's say this first sub graph is 0 to 0, 1, 2, 4. Okay. So this is your first sub graph. Now you see this. If I want to make this acyclic, right? Or if I want to just minimally connect it, can I remove 1, 3 edge and still my graph be connected for this subgraph 1? Can I do this?
Yes, sir.
I can do this. So if I remove this edge 1, 3, still my graphs is connected, and you see it forms a tree. Like at least this subgraph forms a tree, right? Now having removed this edge 1, 3, there are other 4 possibilities of removing the second part of it, right? So if I remove 1, 3, and from this second subgraph, I can remove either 3, 5 or 5, 6 or 6, 4 or 4, 3 for it to make it a what? Not a acyclic, but basically a tree, right? A spanning tree. So what are we doing here is, first you will see, all I have to make sure this graph is minimally collected and it is a tree. Basically it's a spanning tree, right? So if I want to make sure this is a spanning tree, I have to first make sure it's a tree and all these vertices are being connected, right? So if I just remove this edge 1, 3, let's say if I'm removing this edge 1, 3, so what happens? I will have this subgraph will be a spanning tree, right? Only this subgraph, but this is still not a this subgraph 2 is still not a spanning tree, right? So I have to make sure even that is right. So what I can do is I can remove any other edge. Like I can do this in a 4 possible ways. I can remove either edge 3, 5. If I remove edge 3, 5, what do I get? It will form a tree. And it covers all the vertices, right? So you see this, by removing 1, 3, I have 4 ways of removing this second graph, right? Similarly, if I remove this edge 0, 1, I still have 4 ways of removing this subgraph, second number subgraph. Similarly, if I remove this edge 0, 2, I still have 4 ways of removing this, right? And similarly, when I do this for 2, 2, 4, if I remove this edge 2, 4, I can still remove any of these vertices in second subgraph, right? So essentially over here, I have 4 possibilities of removing edge, and over here also there is a 4 possibilities. So essentially 4 times 4, it turns out to be 16, right? So how many spanning trees you can have? 16.
Yeah.
Sir, so
Sir, can you please explain once again? I just got confused.
Okay.
sir, could I ask a small doubt based on what you explained?
Please.
Sir, so whenever we are creating the spanning tree, um, we are removing one line from graph 1 and one line from graph 2 separately.
So what are you doing is, you see this, I want to make sure this is a tree, right? So I
Yes.
must remove 2 edge, right? So if I must remove 2 edge, one from the first subgraph and another from second subgraph,
Okay.
right? So what are you doing is, you just try to remove this, you just remove this edge. If you remove this edge, is this first subgraph a tree?
Okay, I got it, sir.
It is a tree. Then similarly, you have to make this second subgraph a tree. So you can do it that in how many ways? 4 ways.
So we have to remove 2 because it will give us the minimum number of edges.
That is, no. I didn't get you. Sorry.
Sir, we're removing 2 lines here because that will give us the minimum number of edges, right?
So you do not, yeah, you can say that it in that way, but do not try to generalize for this particular thing, because you would have seen it in earlier cases wherein we could actually say, okay, we can remove, we can have n-1 edges and all that things. But over here, you have to think it analytically here, right? So you can say that, yes, you have to remove 2 edges from here, right? So that could be done it in 14 ways, 16 ways, right?
Okay.
Yeah.
Yes, sir.
So any other doubt in this particular question?
No, sir.
No, right?
Clear.
It's clear.
Yes, sir.
So now somebody will be like, okay, what is the algorithm to do this? There is no algorithm. If there is, you will not be learning right now, or maybe it's out of our course for this entire BSc degree, or maybe you might learn. So for time being, there is nothing. It's just an analytical thinking that how can you make it a spanning tree, right?
Do you expect this type of question in the end term?
I don't remember we have any questions like this, but it would be good if we have something like this, because like you can have some analytical thinking in your exam.
If it is in the shape octagon and
You see, why we were able to make some conclusion over here was because of this symmetry, right?
Yes, sir.
Right. That is why we were able to think this. So anyway,
these type of graphs questions are too easy, but the limits and logs are really tough.
Okay.
So
it's okay when those are
complete. If the graph is a complete graph, then it will be also difficult to find, sir.
Then also it will be difficult to do this, but over here it was very simple. It's just that you have to minimally connect it, and it's not a complete graph, right? So you just have to remove only very few edges. Okay, so now let's go with some other question. Now let's go with our 2 algorithms, that is Prim's algorithm and Kruskal's algorithm. And I could see like we have half an hour for it to be 6, right? So let's
what is
go
the
in
difference between Prims and Kruskal?
Okay, you will
Can
get this. Yes, you will get it as we are going through. You yourself will be able to know like what it is, right? So you see this Prim's algorithm is used for finding MCST of a given graph G having n vertices. Okay, so how is this done? You incrementally build this MCST of G. So what you do is essentially, so this is kind of important, so you just pay attention to this. So this TV says it's a tree vertices, and T indicates tree edges. Okay, so initially what you do is you initialize this to an empty set. So this is basically a set. TV indicates a set which contains what? Vertices. Which vertices? Tree vertices. And T is also a set which includes tree edges. Okay, so what you do is you will be given a graph. So what you do initially, you write down this TV and T, and you say like, okay, this is my empty set. Okay, So now what do you do then? So now what you do is a graph will be given. From there you will identify the minimum edge, the graph with the minimum edge weight. Okay, so you will identify, let's say that edge is ij and you say that is e. So now what will happen? TV was our set, right? Now TV was nothing but three vertices set, right? So three vertices, which all edges will come here? The one which is of the minimum edge, right? The one which we are choosing. So I and j comes over here, and t is nothing but your three edges. So here ij we are indicating with the e. So what we have written here as a e. Now next step becomes important. Now you have to repeat this n minus 2 times. Then what do you do basically? You will choose the minimum weightage. Okay, so that is something again. This is, let's say, that weightage is nothing but f, which is joining v uv, such that your u must be in TV and v must not be in TV. And then you add what? This v to TV and f to TE. So many things, right? Got confused?
Yes, sir.
Okay, don't worry. I'll come back to this algorithm. I'll come back to this slide again. So
Can you
what I'll
repeat
do
step
is
3?
step 3. Okay.
Yeah.
So what are you doing here is you will be given a graph. Okay. What you do is you choose that edge which has got the least value or the least edge weight or the minimum edge weight. So you select that and you upgrade it in this TV and TE. So what is your TV? TV is nothing but it's a set of three vertices, and T is a set of three edges. So what we are saying is, from this particular graph, we have chosen a vertices ij, and we have given to TV, and we have also naming that ij to e, and we have upgraded this to TE. Don't worry about this. I'll take up this example and then I'll come back to this. Then you'll be able to understand this. Okay. So now you see this. Basically, okay. So here you have the question directly, but it's okay if somebody knows it. If you can answer this, let's see how many of you can answer this. So consider a weighted graph G with seven vertices P, Q, R, S, T, U, V, which is represented by the following adjacency matrix. So if something is given, you basically have to do the graph. And once the graph is done, you will do the Prim's algorithm, right? So let's see first how many of you can do this, and then I'll be explaining you how is that being done, and then I'll take back you to the same algorithm where I'm explaining you this, and then we'll try to correlate whatever we have told is being right or wrong, right? Okay, so we can do that. So now let's see how many of you can answer this. If we perform a Prim's algorithm starting with vertex R, then the order in which the vertices will be added to set of TV is nothing but three vertices is. So that is something you have to enter the letters in an order separated by a comma. Okay. So let's see how many of you can give the answer for this. So do not worry if you don't know this. I will explain you this. But just give a try based on the algorithm, what it is been told, or like from your prior knowledge. Try solving this. So 3 of you have given the answer till now. Do you need some more time?
Yes, sir. 1 minute.
Yes, sir. Yes, sir. Yes, sir.
Okay, so you're solving. Good. Okay, so take a minute.
Still, I'm drawing the graph only. I think I'm too late. I'm spending too much time.
Sir, where exactly do we need to give our response?
Sorry?
So where exactly do we need to give our response? I mean, I've seen that sheet where response of everyone's is being captured.
Okay. You just have to write it there. That's all. You just enter the thing. We'll get the response.
So she's asking how to join that one. Joinpd.com. You need to type joinpd.com and see.
You are asking about this portal itself. Okay, so you have to go to joinpd.com. Go to this joinpd.com and use this code. Yeah, this code, what you see here at top right corner.
Oh, where is the code?
Kim GHK. Kim GHK. That is the code.
Okay. Kim GHK. Okay, thank you.
Done, sir.
Done? Okay.
Yes, sir. Done.
All right. So do you need some more time or should we go with the explanation?
Done, sir. Okay.
Yes. Okay. So let's see what are the popular response. So some of you say R, P, R, TV, R, U, V, P, Q, S, T, R, V, U, P, Q, S, T, P, V, Q, S, T. Okay. All right. So let's check this. We'll come back and check how many of you have given right. So you see, maybe I myself will explain this, how it's happening. So first, there are two parts in this. First of all, you will have to draw the graph for this particular matrix, and then you have to perform the Prim's algorithm. So this topic is something we are discussing, Prim's algorithm. So I'll tell you as once the graph is drawn, then I'll tell you how is this Prim's algorithm applied. And then we see that algorithm, it's happening in the way, whether what is written there or not. Okay. So now first step is that you draw the graph that represents the adjacency matrix, right? So this is something you get. So what
Vicky,
you do
can you
is,
please explain how to draw graph quickly, because I'm taking too much time to draw this graph.
okay. So what you can do here is, see here, you can see this PQRSTUV, right? So you can name these rows and column with the same thing, PQRSTUV. Okay. So I hope you do this. You do this, right?
Yes.
Okay. So once you do this, then what we have to make sure is, since this is our P and this is P,
No,
Q,
do I need
R,
to copy all these in my paper? No need, right?
copy what all these matrix?
All this matrix.
I don't think so. You'll, but I think
that's what I'm asking you, how to make it quickly.
Okay. So one thing is, like, if I was you, I would have actually written this in a copy, and I would have mentioned this as PQRSTUV and this also as PQRST, because when you think that this is PQRSTUV, you might tend to make mistakes. So it's better to write it on the copy and then write down the alphabets over there, and then you find out. So if this is pth row, right? So pth row is this, and this is the columns are P, Q, R, S, T, U, V. So now you see this.
And
when
that's
it is,
what I'm doing, but it's taking too much time. See, this much time I'm since still drawing the graph only.
okay, so it will
I'm
not
doing
take
that
time.
only. I'm noting down everything on matrix on my paper, and I'm then drawing graph.
Okay, so as I was telling you, and how are you placing these vertices? Try to place these vertices in a circular fashion. Okay.
Yes, yes, yes.
So you first write on P, Q, R, S, T, U, V, and blah, blah, whatever it is. Okay.
Yes.
So you
yes.
just write it down. So let's say you start with P. So you see this P is sharing an edge with Q, and here it's sharing an edge with T as well as V, right? So what you do is you just connect those vertices and assign those values over the edges, right?
Yes, yes.
Similarly, you go with what? The next thing, P, after P comes Q. So you see that Q shares an edges with what? P.
With P. Yeah, this is what
S.
I'm doing. Maybe I need more practice to
yes.
do it quickly.
So you're doing it in the right way. It's, yeah. Since you're doing it this way, you are doing it in the right way. So
Same,
you just
I'm doing, but it's taking too much time noting down all the matrix on the paper and again drawing the graph.
It's okay. It's okay. It's okay. Just try to practice, because you see, you might be always given a matrix, because see, this involves 2 steps, and then only we can give you marks, right? If just a Prim's algorithm, then it's of 2 marks. But when it, and this is not right to give just 2 marks, right? So we just try to give some 3 marks or something. So we'll incorporate matrices, and then we expect you to do the graph and then find out the things. Okay.
Then, sir, in final exam, are we going to expect any subjective type question? Because you have said that stepwise marks you are giving. So what does it mean?
No. Step by marks in the sense the marks distribution, what we do. So you would see like there are some questions, some comprehension questions wherein, like you will have sub questions, right? So those kind of questions are there, but I don't think so there is for graph theory. This is something you won't be given a marks for drawing the graph actually, but you will be given marks for what actually you will be doing at the end, like whatever the MCST you will find. So you don't have a step for this basically for graph theory, because it is of 3 marks, and we don't intend to create a sub question, because that will essentially increase the number of questions, right? So we will not be doing that. Okay.
Could you
All
please
right.
do the question once?
Go to the question once.
Yes. So when we start from R, we have to. So where do we go till?
Okay, so since I did not discuss Prim's algorithm yet, so you can just wait. Okay, so I think you are with Dijkstra and other algorithms, so let's not be there still. We are here at Prim's now. So now you see here, basically what we did was, like, from this matrix we have drawn the graph. Now this is something we'll have to practice and learn, and so this is what you do. So now what is the thing? Now we are actually doing algorithm. Okay, so now what are we doing here is we are initializing TV. Now TV is nothing but 3 vertices, and T is nothing but 3 edges. So what are we trying to do? We are trying to build our Prim's. We are trying to find out our MCST, minimum cost spanning tree, and we are not finding the value, but we'll find the value at the end. Okay, so what do you do? Which vertex should you choose first? Which is giving you the minimum value? Could you tell me?
R. Sir, it's mentioned that we have to start from R to U.
So to see this in algorithm, it is told that you should choose the edge, right? You should choose the edge. So that is the best practice you can do. So which edge should you use? You should use
RU.
or RU.
So,
right?
But in the question, it's mentioned that we have to start from vertex R, right? Starting from vertex R, we'll have to apply.
Where it is mentioned?
If we perform Prim's algorithm,
that question it is
starting with vertex R.
So if it is told, then yeah, it's fine. You can start with vertex R. But essentially why it was told was because we want you to go with this flow, right? So when it is told, even if it is not given, so it might give you a hint that there might be 2 edges with the same weight, right?
Sir, because I have seen the same question in graded assignment, and there the vertex is different. The starting vertex is different.
It's okay. So what I'm trying to say here is, here why it's okay, even if this R was not mentioned, you would have chosen this UR only, right? because if you are following the Prim's algorithm, you will
Yeah,
choose
because
the,
it's minimum.
because that is the minimum. So that R was essentially not required.
Sir, had it been mentioned that the starting vertex is P, then in that case, what would?
Okay, I will tell you one thing.
Yeah.
That's something we will not tell you.
Okay.
We will definitely not tell you that, because that will violate Prims. So what
Yes,
we would like to tell you, when we would like to tell you is, let's say if this PQ, its edge weight is 1. Okay.
So the same question is in the graded assignment, and there
Okay,
we'll have
what
to
I'll do
start
is I'll
from
mute
P.
all. Just a minute. Yes, now unmute and speak. Yes.
Sir, the same question is in the graded assignment for week 11, and there we'll have to start from vertex P. So that's why I was asking this.
Okay, so maybe you're just confirming that, but it's okay. But what I'm trying to say is that is nothing to do with this particular question. You can start from the edge, which is the minimum, the least one. Okay. Over here, there is single UR, which is the least, right? Now, let's say PQ has the edge weight 1. Okay. Then where you should have started, which edge you would have chose? You could have either
I could have,
PQ
I could have chosen
RU, right? You could have done this. But
Yes.
if in question it was told that, okay, the first vertex you will take is R, then you would choose this, not that at that point of time. Okay.
Yes, sir.
Now got it.
Sir,
Yes, sir.
if it is not told, then
If it is not told, then it's up to you. You can choose any.
Okay.
Okay. Generally, it will not be told. I don't know why there. It's just given there. Okay. Generally, it will not be told. It's up
sir,
to
the
you.
answer would we would still arrive at the same answer.
We'll get the same answer. Yes, we'll get the same answer.
Even if
What
like
I'll mute
even if-
all again. Then you can unmute. Wait. Yes.
Even if PQ was 1 and UR was 1, right? And we start with different vertices. We
No.
would get the
You
same
should
answer?
either start with UR or PQ in that case.
No, we would start with either. Some of us will start with UR, some of us will start with PQ.
Okay.
But
Yes.
the end answer will still be the same for all.
Yes.
Okay.
Yeah. So now let's start with this, but we will always tell you what order you have to follow.
Because
Maybe
the
we'll tell you follow the
MCST is
alphabetical
unique,
order.
sir.
Huh?
Unique.
Yeah,
MCST is unique.
Yes.
That's why.
Okay. So now
Sir,
let's.
can we move to the answer, please?
That's what, like, you're not letting me go. I mean, it's okay. You have doubts, so that's okay. So now let's discuss this. So since forget there was no R, now which edge you should choose? You should choose UR, right?
Yes, sir.
You should choose UR in that case, right? So what, when you're choosing UR, you should directly give your TV as UR. Okay, over here, since it was told in the question, start from R, that is why we gave TV. Your first entry of the vertices in your TV turns out to be R, and T is something still not something we don't know still. You can either go to TV or TU, right? Where you should go to TU, right? Because that is the minimum, right? So this starting one is the problem. So you either choose the edges or like the one which is told in the question, starting from R. So what you do is the simplest thing to do is choose an edge. So you choose UR, whichever is the minimum one, choose UR. Okay. So now what, your UR comes in the list. Okay. So now you see this, your T. Now you look at this part, this update thing, what we are doing. Now in TV, I have two vertices, that is R, comma U, and in TE I have the edge RU, right?
Yes,
over here, no doubt.
No, sir. No, sir.
So now,
Can
now
you
from
repeat it once again?
now what I will do is now look at this, how we are going to the other thing. Okay, now this becomes important. Now whichever is there, whichever vertices which comes in TV, right? So what you do is essentially you find the other vertex. You find the other vertex, but you have to make sure that that is joining in any of the vertices which is in your set TV. Okay, am I clear on this?
Can you come again, sir?
Okay, so now you see this. What we did was we first selected UR, so or RU. The RU comes in our TV list, right? TV set, and in TE set we have R comma U. This is still here. This is okay, right?
Yes.
Now Now I want to go to the next vertex, which has the minimum weight. Right? Now I have to choose the next edge, which has got the minimum edge. Now from U to V, I can go to U to V or R to V. So which one should I choose?
R to
RV. Okay. But what is the condition when you're choosing this? When you do this, you have to make sure that U and R are already there in your TV. I cannot have edge with S and T. Why I'm not choosing this? It's just because
not in TV.
Because it's just because S and T are not in my TV. Clear?
Yes, sir.
And it's not connected with.
And it's not connect. It's basically not connected with the vertices or with the edge we have selected. Or like
and this thing we can do only in Dijkstra algorithm, I think. Yeah.
So you go with Dijkstra like that. But here in Prim's, what are you doing is you will select the next edge such that you will choose those vertices, which is already there in TV. Like if I have to take you to the algorithm, and if I show you that algorithm, what does it say is that you choose the minimum weight edge FUV such that U is already there in TV, but V is not there in your TV. You see here at my cursor?
Yes, sir.
Right? So you have to make sure that you are going to the next vertex in such a way that the earlier vertex, the V vertex, is already there in TV, right? So I cannot take any other vertex from anywhere else, right? So that's what we are doing here. All right. So having known this, we will build our MCST. Okay. So now what? Now from here, now I can only go to any other vertices from U covering, touching either U, R or V, right? So you see that I have already covered this. Now I have to choose the next vertex. So the next vertex would be P, right?
Yes, sir.
Why are we not taking UV?
There,
It is already
5,
in the
sir.
list.
That is
Because it will create a
weight
cycle.
will be
Because it will
cycle.
create
a cycle.
Yes.
Ah,
So we
okay,
have to
sir.
make sure that there is no cycle formation. So whenever you select a next edge or when you go to the next vertex, make sure that there is no cycle formation. Right?
Yes. That is why they asked that the other vertex should not be there in the set already. It is
Exactly.
already in the set.
Right.
And because
So-
it is also, we have to create a tree.
Right. And we also have to create a tree. So because of that reason, and we have to make sure that there is no cycle formation. All right. So now from V, we have went to P, right? And now the next thing which comes is Q. Because
Yes,
see, from
Q.
P, I can go to T, I can go to Q, but which one should I go with?
Q.
The one which is minimum.
Yes,
So
sir.
which is minimum? The Q is minimum,
Q.
right?
Q.
So you go to the Q. So now Q comes in your TV list, and next your edge PQ comes in the list, in TE list, or right. So now the next
Yeah.
entry is you can either go to now you can either go to QS or you can go to PT. Whichever is minimum, you can tell me which is minimum.
QS.
QS, sir.
QS. You can even take this, right? You can even take this because this will not create any cycle, right?
Yes, sir.
You can
Yes,
take
sir.
this also, but whichever is minimum, you have to take. So which is minimum? QS is minimum. That is why the S comes here in your TV list, and this edge QS comes in your TE list, okay, or TE set. So now this happens. Now what? Which one is giving you minimum? QT is giving you minimum or PT is giving you minimum?
ST.
Sorry, ST is giving you
ST.
minimum, right? So you will go with the ST. So now T comes in your TV list and ST edge comes in your TE list, right? So now you will have this. So now, so finally, what do you get in your TV? R, U, V, P, Q, S, T, right? So this is the tree vertices that you get. And you see this is marked here in the green.
I have one doubt here.
Okay.
To reach from P to S, PTS is 11, PQS is 14. So why do we choose PQS?
Yes, sir. Same doubt.
Yes, sir. Same doubt.
Okay. Come again.
PTS. It is 11.
Okay.
P to T, T to S.
From where are you
P.
going? Which is your source vertex and which is your this thing?
Till P, it's okay, clear. Till P.
Till P is clear. Okay.
P to S. P to S, we have two paths. PQS,
Then we have to
PTS.
go to the Q also. Then we have to
Yeah,
match
yeah.
Yes, sir.
Q
But
also.
PT is
Yeah,
9.
sir, understood.
PT
When you
is
go
a
for
higher.
PS Q.
I think you yourself understood this, right?
Yeah, I didn't get it. So
You
because
didn't get it?
PTS is if we calculate from P to S through T, we get 11, 9 plus 2. And
No, we
See,
are
first
getting
of all,
17.
What about Q?
What
P,
about Q?
T,
Yeah,
S,
if we
Q.
connect PTS, then we have to connect P to Q. Then that will be 17.
Yeah, yes.
We can't left a Q.
19,
so,
it will be 19.
Yeah, we can't leave the Q.
so it'll be 19 and 19 and
I have a question.
okay, 19 and 16. So the other one
Yeah,
is
we have to go through all the vertices.
Yeah, is it must that we should include all the vertices?
Yeah, it
yes,
is.
yes, yes. It
Yeah,
is
it is
must.
must.
Okay, thank you.
Yeah. So all right. So now this one is this is what you get from here, right? So I hope this is something understood.
Yes,
Sir,
sir.
one thing, sir, is it wrong if we plot from U or V like this?
From there?
So
U?
from U, sir, from U or V, raise them.
No, you can actually do that as well. You can take U or V as well. But since it is telling in the question that you have to start from R, right? Because the
Yeah. Yes,
so that is why you have to start with R.
I'm just asking this.
Yeah, but in the question, generally in the question, we won't be telling you, okay, start from R or something. We might tell you, okay, start with any pair. So you'll find MSQ type questions, right? So you will find either UR or RU, right? So that is all. That is something you will get. Okay, so what things we have to keep in your mind here is, first of all, follow the algorithm. You have to select the edge which is of least cost, right? So over here, UR was the minimum one, so we chose this, and U and R came to our TV list or TV set, and T is the edges, tree edges, right? So this is a set. So now which is the edge we should select? UR. And now you start building your MCST. And how do you do that? You do it by extending this edges to your neighboring vertices such that it covers the minimum edge, right? It covers the minimum edge weights. So that is what you do. But you make sure that whichever edge, whenever you're doing this, there is no cycle formation, right? So that time I asked you, can we go to U, V to U? If you come to this, you form a cycle. So you will not do that, right? So that is something you have to keep it in your mind. All right. So this is about Prim's algorithm.
Okay.
So the answer is RUVPQST. Okay. So if you did not get it, try to solve this again, you will get it. Okay. All right. So now let's go with the Kruskal's algorithm. So now what does Kruskal algorithm tells you is, what you do here is you again incrementally build an MCST tree of G or your graph. What you do here is you select edges. Basically, whatever the edges are given, right? Whatever the edges are given, you arrange them in an ascending order, right? So ascending order in the sense from the minimum weight to the maximum weight, you arrange them in an ascending order and you put it in a set called E. Let's say that is an edge set, and this E set is such that all the edge weights are mentioned there in an ascending order of their weights. Okay, so now what you do is, now you build your TE, that is your tree edge, and you initialize that to an empty set, right? So now what you do, from this edge set, from this E set which contains an edge weights in an ascending order, you choose the one which is of minimum value, right? So let's say the minimum value was E, okay, E0, and then you go with the other edges such that there is no cycle formation. Okay, so you do this way. Okay, if there is a cycle formation, then you skip that edge, you will not take that an edge. Okay, so now let's discuss this. So here again a same thing is given, adjacency matrix is given.
The last 2 points.
You did not get the last 2 points, so don't worry about this, we will explain you this.
Okay.
So what I'm trying to say here is, so over here maybe I'll not give you time to solve this, since this matrix is already given, you can actually draw the graph and then you have to find out the tree edges, and you can actually do this. So in any possible ways, you can either use Prim's or Kruskal's and give me the answer. But over here, I want to discuss how is this Kruskal's algorithm perform. So what you see the graph, you get something like this. So what does algorithm tells you is, you create a matrix E, not a matrix, but what you do is you create a set E, and you in that set you select all the edges in an ascending order. You list all the edges in an ascending order. So you see RU was the minimum one, so that edge comes the first one. Then you see ST was the next minimum one, that is something written here, right? And then next comes the RV, right? So RV is 3, right? So that is something written here. So all the edge weights in their ascending orders are written here. Now we have to do is, all we have to do is, now we have to select from this, right, the one with the minimum edge weights, right? And then what you do is you just put it in a tree edges, right? And you do it in such a way that there is no cycle formation. Okay, so still if you have doubt, maybe we'll take up the questions, maybe we'll discuss this as we are going through, and then you'll be able to understand. Now what you do, you initialize your tree edges to an empty set, and then you scan all the edges starting from an edge RU, because this is the least one, right? So you start with RU and you start adding the edges to TE and build MCST. So now you see here, now this is your set E, which contains all these edges in an ascending order, right? So now what we have to do, what we have to add edges to TE such that it is of minimum cost and there is no cycle formation. Now TE, if I select, now you see T in my TE, RU comes in, because that is the least edge weight. So you know that RU is the bottom one. So you see that comes here. Now which is the next edge we should take? ST. So can I, if I take ST, is there any cycle formation?
No, sir.
There is no cycle formation. So I can give that to my number here. So I can actually select that edge now. So now you see that ST comes in the picture. All right. Now what? Which is the next thing? RV. So if I select RV, so where is RV? RV is here. So if I select this RV, is there any cycle formation?
No, sir.
No. So there is no cycle formation. Then that will come in my tree edges list. So you see here, tree edges is being built, right? And how is that happening? I'm selecting the edges, but I'm making sure there is no tree formation, right? Now next, what about UV? Can I take UV?
Sir. No, sir.
No, sir, it forms cycle.
So I will
Create
not
a cycle.
Yes, so that will not come in my tree edges. So I will skip that, right? So I'll skip that. So that is something marked in the red, as you can see. Now, can I select PQ?
Yes.
Yes, sir.
I can select PQ, right? Because PQ is here and there is no cycle formation. So now what? PQ comes in here. Now what about PV? Can I take PV?
PV.
Yes,
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 sir.
sir.
Yes, sir.
Take PV as well. So PV comes in. So here comes PV. So PV comes in our tree edges. Now you can see there. All right. So now, what about QS? Can I take QS?
Yes, sir. Yes, sir.
Sir, you can.
I can take QS, right? So now I'll select them again. Is there any tree formation? There is no tree. Sorry, is there any cycle formation? So no.
No, sir.
What about PT? Can I take PT?
No, sir.
No, sir.
No, sir.
No, sir.
Create a cycle.
No cycle.
Cycle.
I'll skip that. Will not take PT, right? So then what do we get then? Adding PT will create a cycle. So we'll skip that, right? So what is our tree edges? So our tree edges are RU, ST, RV, PQ, and PV, right? So this is my MCST, right? So what is the cost of this MCST? Can you tell me?
Sir, QS also.
Huh?
Minimum.
Sir, so in TE QS also there is missing some QS.
Okay, yeah. Okay.
And 27.
Okay, so this is what you get, QS. So yes, that was not shown there. I thought I showed you the last slide, but okay. So now you see this. This is what comes in my. This is what the order you have to follow, and this is your tree edges. So we might ask you, okay, which among them is the tree edges? But the question will be, what is the value of this? We will not ask you this sequence, but could you tell me what is the cost of this MCST?
27.
27.
So now what you will do, you will just simply add them. So 1 plus 3, 3 plus 7, it's 11. 11 plus 6, makes it 17. 17 plus 2 makes it 19. 19 plus 8 makes it 27. So the cost of this MCST is 27.
So,
Sir,
but
this
like,
is
how do
quite
we
easy.
arrange?
Okay. So now one more thing. What is the cost of this previous one that we did it, like Prim's algorithm? We
Same.
did that Prim's algorithm, right?
Same, sir.
Same, sir,
27.
27.
Same, right?
Yes.
Yeah. Okay. So not here. So maybe, so you do it in any ways you want, you will get the same thing. So you see this, this is what we got, right? This sequence we got. So now what, it's essentially the same thing, right? It's 11. 11 plus 6 makes it 17. 17 plus 2. 19 plus 8, 27. So it's the same thing, right? So you can use either of these, you will get the same cost for them, both of them.
So,
Okay.
but how do you arrange the vertices while?
So that's what I'm telling. So what you do here is only two things you have to keep it in your mind. First of all, whatever the graph is given, remove all the edges from the graph. Okay, just make it like this. Okay, and you arrange that edges in an ascending order. That is something done here. And then you start building your TE. And how do you do that? You select the one which is of minimum least cost. So you put it in your TE, and you start taking out the other one. You start building the other one. I mean, you select the other one in an the order which comes the higher than that, right? So you select it. Now here it was ST, but each time when you take the next edge, you make sure there is no cycle formation. This is all about the Kruskals. But in Prims, what you are doing, you first chose the minimum edge weight, and then you started building your tree, right? You started building your tree thereafter, and you were making sure that there is no cycle formation, and also that whenever you are building a tree, you are making sure that the earlier vertices, or like the U vertex, was from the existing TV, right? And that's how you were building it, right? So that is what you do. Okay, so clear?
Yes, sir. But what happens when the two weight is same?
When two weights are same, you can choose any of them. Let's say RU and ST has got the same weight, so you have the privilege to choose either this or this, any of these. In that point, what happens is your sequence will be different, but the cost will still be same.
Yes, sir.
Okay. The sequence will be different at that point of time.
This method is quite easy.
Depends.
When the graph is too much tricky.
Then you can actually do this, yeah.
Where?
But again, see here, this is kind of a bit cumbersome in a way, because you will actually have to write down all these in an ascending order, and then you.
But in the examination, you ask is it find from Prims or Kruskal?
No, you can choose anything. Even if we tell you do with the Prims, you do with the Kruskals and get the answer.
That's
okay?
easier.
So you can do it in whichever way you want.
In Prims and Kruskals, what is the difference?
So now you got the difference. See what actually the algorithm
This
is
should have this should not have a cycle, and that can have a cycle.
So that is not a difference. That is a common thing. Both of them should not have a cycle, right?
Sequence of TEs are different for both now.
It's just the steps what you are doing is different.
Yeah.
The algorithm is different, but in each time you are making, there is no cycle formation. That is the only difference. Over here, what are you doing? You are just removing all the edges, writing them in an ascending order, and then choosing them one by one, making sure that there is no cycle formation in Kruskals. But in Prims, what are you doing is you are basically first choosing an edge, and you are building your TV. You are building your TV, that is 3 vertices, and making sure that you are extending the tree by choosing one of its vertices from the TV, right? And then choosing the minimum value. So essentially, why you are doing this is you are avoiding tree formation. Okay.
So in this,
sorry, not tree formation, but cycle formation. I'm sorry.
So I just wanted to ask, in this we could get away without drawing the graph. We could use the adjacency matrix to identify the edges in say this ascending order. Is it possible?
Possible, but you should practice. You can do that practice thing.
So we should draw the graph.
See, essentially, like
no need, I guess, because there is
no need,
R to U.
Like you did it with only vertices. Yeah, you did it.
You can actually do that, right? You can actually do this. You can just see that matrix and you can actually select the one, but you need a practice. You should practice if you want to do it that way. Okay.
True.
Okay.
So
So
for
now
this
those.
kind of, sorry, sir.
So
So
yeah.
for this kind of questions, we'll always be given the graph, right? Because the way I get my graph is very different from what is there on the screen.
It's okay. It doesn't matter like whatever the graph is, but all you have to make sure that you are giving the same edges for them, right?
Okay.
Yeah. It doesn't matter like how distorted the graph is. That is okay. That is not a problem.
Okay. Sir.
Yeah. So all right. So see, those who want to leave can leave, because the whole point for doing this was your algorithm. This one, basically your Dijkstra and Prim. So that is something done, and rest all is done in the previous live session. Those who wish to leave can leave. I will quickly discuss the other thing. You can stay with me because I know that you have a CT session. So,
Sir,
like
as I
said,
I want you to even Bellman Ford.
Maybe before going to Bellman Ford, I want you to discuss this. Maybe
Floyd-Warshall. Anything is okay.
Okay. So those who want to stay can stay with me for some more time. I will explain you the other thing like Bellman Ford and then Floyd-Warshall. And yeah, that's all, I guess. Yeah. So these are the other two algorithms which I can discuss with you. So you see this Floyd-Warshall algorithm, what you do, you compute the all pair shortest path. And this algorithm is actually not tougher than the Bellman Ford. Bellman Ford is some kind, what I feel is it's kind of time taking, but Floyd-Warshall is not. But how do you do this, right? So I just don't want to go with this algorithms and all. You can see this algorithm. I'll just explain you this with the graphs. So what you usually see questions like this. I'll take this SP. Maybe I can take this SP3 and explain you this. So whenever we say what is this SP3, SP4, SP5 or something like this, right? So what do we really mean by that? See, it means that you have to find the SP is nothing but the shortest path. And this 3 indicates that you are going through 3 vertices. Okay. So 3 vertices in the sense, you see this, you are actually going to vertex I to vertex J, and you have the freedom to go through these vertices. That is 0, 1, 2. I don't know how far you understood this. When I write SP5, what does it means is you are finding the shortest path via going through vertices 0, 1, 2.
0, 1, 2, 3, 4.
Okay. So now you would understand this, that whenever we are saying SP3, SP4 or SP5, or let's say for SP9, these are independent of each other, right? It's nothing to do with what is given in your SP3 or it's what is given in the SP4, right? If I have to tell you, you find out SP5, you no need to find what is SP0 and what is SP2 and what is SP3 and what is your basically SP3, right? So so this is what you have to keep it in your mind. They are not dependent. I mean, SP3 is independent of SP0 and SP1. All right. So how do we do this? Now I'll tell you that.
Sir, I have a doubt. What is SP3?
So I'll tell you this. And stop me wherever you have doubt, okay? Yes. So you see this, SP is the shortest path, and 3 indicates that you are allowed to go through vertices 0, 1, 2.
Okay.
3 indicates that. Okay. When I say SP5, then it means you are finding all pair shortest path via vertices 0, 1, 2, 3, 4. When I say SP5, then you will go till 0, 1, 2, 3, 4. So you have the freedom. Sorry?
0 is always there.
0 indicates the first one, the first thing, and second thing, third thing, fourth thing, fifth thing, right? So it's just this. Okay. So now let's discuss this. How is this happening, and how is this matrix filled here? Okay. So now let's understand this.
Hello, sir. In place of 0, 1, 2, can it be like for
ABCD.
SP3? Can it be can it be 1, 3, 4 or 1, 2, 4 something?
You can give it as A, B, C, D, E. When it is A, B, C, D, E, then what? When we write SP3, it means what? A, B, C.
Okay.
Clear?
Got it.
Okay. So now let's see how we build this matrix. Then you will understand this more. Okay. So it's okay if you understood a bit. It's fine. So now let's understand this sp3. So when I explain you that sp4, then it becomes much more clearer. Okay, so now you see this sp3. What are we doing here is, when we say sp3, so I am finding the all pair shortest path, and you are allowed to go through these vertices 0, 1, 2, right? So now you see this, what we are doing. From 0 to 0, is there a path? From 0, where all I can go? I can go to 1, I can go to 4. Can I go to 4 and come back to 2? No, you are not allowed to go to 4. Why? Because you are only allowed to go to vertex 0, 1, 2.
Yes.
Right? So I cannot go to 4. That means I cannot come back to 0 when in sp3. So what is the distance then? The distance is infinity. Or basically there is no distance. Okay. What about 1? Can I go to 0 to 1?
There will be no path, I guess.
0 to 1, there is a path. And what is the path? 1. Okay. What about 0 to 2? Is there a path?
No, sir.
No, sir.
I can come to 2, but I can only come to 2 via 4. But 4 I cannot explore because of sp3. Had it been sp4, yes, I could have thought of. No, in sp5 I could have thought of.
5. Oh, yeah.
Yeah, sp5 I could have thought of. So maybe I'll give you that sp5 to find out. I will explain you sp3 here.
It is
All
0
right.
to 0, 0
Okay.
to 0.
So,
You go
just a
to
minute.
0 to
Just a
1,
minute.
1 to 2, and 2 to 0.
What about 0 to 3? Can you go to 0 to 3?
No.
You can
Yes,
actually.
sir.
Yes, sir.
You can
Zero,
do. The going
zero
part
to
is
1, 1 to 3.
They are saying the vertices should be 0, 1, and 2. How can we go 0?
No. It indicates that you can go to this particular vertex via this vertices. In other words, can I come to 2? So I can come to, let's say I'm going from vertex 1 to 2. If I have to go to vertex 1 to 2, I can only do so by going via vertex 4. But that is something not, but that is something you are not allowed to do because of this reason. But from here you can go to this vertex. That is okay. But you are not turning back. You are not coming back. Via means you are going through that and coming back, right?
Okay.
Right. So from 0 to 3, if you want to go to, yes, you can go because you are going through this vertex. So 0, 1, and next is 3. So you can go to 3. You are not coming back from 3. You are stopping there. So it's done. But you have to make sure that's one step path. Let's say this arrow was pointing at 4. Okay. And you were asked to go to 4 via 3. Could you do that? You cannot do that because this does not come here. Right. Similarly, you will do for 1. So now, can I go to 1 from 1? Can I go to 1? Can I go to 0 from 1?
Yeah, 0 from 1.
Yes.
Yes, sir.
Okay, sorry. Can I
no,
go
sir,
to 0
no.
from 1? Yeah.
No, sir.
No, sir, 0 from 1.
You can go, but if this was allowed, if
4.
you could have gone through vertex 4.
So the
as of now,
second
no.
one must be
But there is an arrow.
from the sp3.
There is an arrow.
Sorry?
But there is an arrow from 0 to 1.
0 to 1, there is an arrow, but you see, you are allowed to go from 0 to 1. It's not 1 to 0. I'm here in the second.
Okay.
This
So
indicates.
yeah, means the second element must be one of the green ones.
Could you repeat again?
So VR means the second element should be one of the
green one. Yes.
Okay.
So that means
if it's sp2, sp3,
okay.
sp5.
Okay, now let's now let's go to entry number 4. Then you will understand this much better. Now let's say I want to go to vertex 0. Okay. From 4 I want to go to 0. So can I do so? Yes, I can do so,
Yes,
because I'm allowed to go to 2. Right? I'm allowed to go to 2 and then 0. So what is the age weight then? 4 minus 4 gives me what?
0.
0. So I got it 0. Similarly, can I go from 4 to 1?
Yes, sir.
Yes, sir.
I can go this way because I'm allowed to visit these vertices. If there was a path like this, I would have not chosen this path because I'm not allowed to go through 3. Okay.
Yes, sir.
Right. Similarly, can I come back to 4? Sorry, can I come back to 4?
Yes,
4
sir.
to 4.
Yes, sir.
Yeah.
Actually, yes, because you see,
Yes,
I'm allowed to go to
4 to 2, 2 to 1.
0. I'm allowed to go to 0. I'm allowed to go to 1. Now it's just
Yes,
I'm
sir.
coming back to my own path, right? So I can do this. I'm allowed.
Yes,
But
sir.
I'm going via these 3 only, right? I'm not going via any of unshaded one. isn't it?
Yes, sir.
I'm going via these vertices. Any confusion here?
No.
No, sir.
No, sir. No, sir.
But for 4 to 1, we're getting 7, right?
4 to 1, you are getting
No.
7.
The shortest path would be 4 minus
4
4
to
plus
And
4
1.
and
Yeah.
1.
1. Yeah. So this would
4
be
to
the
2,
path.
2 to 0, 0 to 1.
You will not
That's
be
why it's
going
1
to
in the graph.
yeah.
Matrix.
Yeah, in the matrix. 4 to 1. Okay. So clear? So you could have gone through this way as well as this way, but whichever is minimum, that is something you will enter in your matrix. Okay. So
But
now
about this infinity, why did they
infinity
put it in?
is something that you cannot
There is
go
no
to that
edge?
part. It's basically
There's
you
no
cannot
edge.
go.
There is no
Pardon?
way.
There is no edge.
Not
That
only
you
edge,
can
no
say
connectivity.
no connectivity as if now, because if you were allowed to go through other vertices, there might have been a connectivity. But when it is being told that, yeah, you are going only through 0, 1, 2, then yes, this is the case. Okay.
But there is a chance.
Yes. Yes.
Uh,
Yes. What is the question?
Does it matter the sign one? So can I say that the -1 is smaller than 0?
Yeah, that is definitely right.
Okay, so in place of 4 to 4, if there is a weightage where I get the -1 and in another way we get 0, then in that case we will consider -1, right?
Yes. Yes.
Okay, yeah, thank you.
Yeah. Okay. So now having known that, you know this, you are allowed to go through SP3. Now let me quickly ask you, what if you were allowed to go through SP4? That means which all things will be marked in green?
0, 1, 2, 3.
0, 1, 2,
2, 3.
So that means you can actually go from 4 to every other vertices and come back to 4.
Yes.
But you cannot do this. You cannot suppose you are going to 2, right, from 1. So you cannot go via 4 because 4 won't be shaded in that point of time.
Yes, sir.
Okay? Right.
Yes,
so
yes,
this is one thing which you can try. Right. You can try doing this.
So SP4 will be having 0, 1, 2, and 3.
SP4 will be what?
0, 1,
yes.
2,
You can
3.
go via
2
0,
and
1.
3, yeah.
Right. So that is okay. I mean, you can try this later on. Right now, you try this, but okay, maybe I can explain you that right now here, and I'll ask you SP5. Okay. So you see here, over here, you were allowed to go to what? These vertices, 0, 1, 2, 3, right?
Yes.
And you cannot go via 4. Now what? Let's look at this only. Look at this 4 from where all we can go. So now you see that.
Up? Can you scroll up?
Scroll up.
Yes.
Maybe I cannot do that.
Because I'm not able to see the bottom.
Right. I know. Yeah, maybe I just have to wait for a minute so that this goes down.
Sir, one thing, sir. All other vertices I understood, sir. From 0 to 1, I didn't understand.
0 to 1, you didn't understood. Okay.
0 to 1, how it is 1? It's
now
no
you can see the
vertex.
screen, right? Properly.
Yes, sir.
Yes.
The lower part.
Could you tell me again? Yes. Tell me which
From
part
0
you
to
didn't
1,
understand.
sir.
0 to 1.
1. How it is 1, sir? There is no vertices where we are going. We are passing by.
No. It's not required actually. If you can directly go, then it's okay. No, it's actually going to that. It's not mandatory that you have to go via that.
Okay, sir.
Understood, right? It's not mandatory that you have to go via this. If there is a path, you can go directly.
Okay, sir. Thank you, sir.
Right? Yeah. So, for example, when it is SP0 means you are not going through any of this. In that case, what you will do is whichever is the first path length, that is the entry value, will give it to that. Okay.
Can you come again? SP0.
SP0 means what? You are allowed to go through. You are allowed to go through nothing in the sense the very first vertex.
Yes,
or
sir.
basically
Simple adjacent matrix.
Yeah, exactly. Just a simple adjacent. So now what about SP4? Now you can see that. Now if I go to 4, see earlier in SP3, I was not allowed to go to, no, I was allowed to go there. So you see that SP3 and SP4 are, it's basically the same matrix. Right?
Yes.
There is not much change.
Yes, sir.
So now let's go with SP5.
Sir,
Tell
can
me.
you please? Yes, sir. 2 and 2 comma 3 is a SP. 0, I mean 2 to 0 is a -4 and 0 to 1 is a 1 and then 1 is to 3 to 9. 1 answer, then why are -1 and -1 update?
Here.
Yes, sir. Yes, sir.
2 to 3, is it?
Yes.
Okay. So now could you tell me which path would you follow when you want to go to 2 to 3?
0 to 0 to 0, 2 to 0, 0 to 1 and 1 to 3.
So what will be the value?
Oh, sorry. Yes, sir. -1. I'm sorry.
Right? Okay.
Yeah, yes, sir. Yes.
Okay. All right. So now try out this one. Or maybe I'll not let you try out because we don't have time. Okay. So maybe I can just explain you Floyd-Warshall like that. You can actually do this. Now over here, I can go through all other vertices. Now I can go to vertex 0. It's SP5. So SP5 is essentially the most important thing. It's because this will actually give you the all pair shortest path when you are traveling through all other vertices, right?
Yes.
Right? If a graph has a 5 vertices, and if I tell you to find out all pair shortest path traveling via all vertices, then it will be SP. If let's say if a graph is of vertex n, and I tell you find out all pair shortest path, and you have a freedom to go through any vertices, essentially what are we asking you? We are asking you SPN, right? And that will give you the all pair shortest path. So over here, you are allowed to go to all other vertices. So now you see this. Now you will have interesting thing. Look at this vertex 3. Can you go from vertex 3 to any other vertices?
No, sir.
No, sir.
No, sir. There is no outgoing edge.
No edge.
Okay. And note this over here, 0, 1, 4, 2. It forms a cycle.
Yes, sir.
Right?
Yes, sir.
So you see this, what is the weight for 0 to 1?
0 to 1 is 1.
What is the weight to 0 to 4?
0 to 4 is 0.
0.
And how is that 0? Just that you are following this path, right? Okay. And what is... Okay, I'll just mute all. Okay. So now, could you tell me what is a path from 4 to... Okay. So what essentially, one important thing what I would like to say is, like when there is a cycle, okay? When there is a cycle, so when you have a cycle, the vertex is reachable in itself, right? You can travel around and you can come back to itself. So you see from 0 to 0, if it is there a cycle, you can come back to 0 to 0, right? Which path you will follow? This one, right? And what is the weight you will be given? 1 minus 1 is
0.
0.
And then you go to 4, and 4 minus 4 is
0.
Similarly, if I go to 2 to 2, then what is the value you get?
0.
You get 0. What about 4 to 4?
4 to 4 also 0.
0. And what about 1 to 1?
0, sir.
So if there is a cycle, and if you are coming back to itself, to the same vertices, whatever is the weight of that cycle will be the weight of that.
2 to 2 will be 0. 2 to 2 will not be 0.
How
Why? It will be 0.
No, it will not be 0.
So how?
Okay. You are coming
0, 1, 4.
2 to 2, right? So which is the path you will be following? You'll go to 0,
2, 1,
1,
0,
4, 2,
4,
2,
and 2, right? So 4 minus 1 is what?
No, 2, 1.
That's correct, sir.
No, you
3
don't.
minus
No.
1. No.
We have to take the shortest path.
Shortest path only.
You
It
have
is
to take
0
the
only.
shortest path,
2
right?
to 0.
It's not 2 to
1 and minus 1 will cut off,
Okay,
and 4
no,
minus 4 and 4 will
Yes, sir.
cut
It will be 0.
It will be 0 only.
0
You have to
only,
take the
sir.
minimum value.
Okay. Yeah.
So in other words, so see this, now understand this, since this is SP5 and this is all pair shortest path. So if I have to tell you, okay, from 4, if you want to go to 3, what is the shortest path?
From 4 to 3.
Yeah. What will be the path length? So it will be 2. So, sorry, what did I ask? 4 to 3, right?
3 to 3 is 3, sir.
There is no other edge.
There is no other edge. 4 to 3 is 3. You either travel through this path.
Yeah,
or
that
this
also 3,
path.
sir.
That's
Both of them will cost you 6. Okay. So now what about if I ask you what is the shortest distance to go from 1 to 2.
1 to
1 to 2.
3.
So all you do is you see your matrix 1 to 2.
Yes,
3.
it's
3,
3.
sir.
3.
So this one SP5 or SPN gives you all pair shortest path, right? And you see that it
But
is
there
not
are only
depend.
5 vertices. Why we are doing SP10?
No, I'm just telling you on general. Like if it
Okay.
is SPN, yeah, okay, you were asking me like this, right? So whenever you have been asked like this, so essentially that SP, if you have been given 10, right? If you have 10 vertices, so SP10 would actually give you all pair shortest path
Obviously,
traveling via all
because
vertices.
you can travel through any vertex.
Right.
But it will take too
Got
much
it?
time, sir. For exam, it will.
It won't take much time. You will be able to do, but we won't give you 10, of course. I mean, we'll give you smaller thing.
I
Plus,
have a question.
there is a high likely chance you will make error. I mean, even if you give me or any other who is very good at it, even they have, I mean, of course, they'll be super cautious. That is what we have to do. That is the only thing. So one thing is you have to, graph theory is kind of easy. Once if you know how to solve it, that is one step. And the second step is how to be cautious. That is also you should learn here. If you are not, then you will lose marks, even after knowing the steps and everything. Okay.
So could you
now-
please explain from 1 to 2?
Okay, 1 to 2.
Yes, sir.
Okay, so 1 to 2, right? So which path will you follow?
1, 4, 2.
So what is the weight you get?
Oh, so I was adding 3 also.
Okay.
I have a question.
Yeah.
Like I think you started from SP3 directly, right?
What I was trying to say is, whenever we tell you SP3, SP5 or SP10 or whatever, it doesn't, this is not at all dependent on the previous thing. It's not at all dependent on what is your SP0 or SP1 or SP3 or SP4 for that matter, right? All we have to know is which all vertices I can travel through. That's all.
So can I also start from SP5 itself?
Hmm?
Can we even start from SP5 directly?
If it, yeah, you can actually do SP5 directly. If it is asked to find out SP5, you will not do SP0 or SP1 or SP2 or SP3 or SP4 or anything. You will directly do SP5. But I think in your practice assignment, one of the method is been told like, oh, you have to do that thing. Right? It's actually my handwriting only. I myself has given that. But that is one way of doing it. I mean, but that is very long process.
Yes, it is very long, making so many matrices. But then all we need is
I'm sorry
clarity
about
on
it.
this.
I'm sorry about it.
So we need
Okay.
just clarity that if we are doing SP5, what exactly we are doing. That's all the clarity we need, right?
So the clarity over here is when it is SP5, you don't do anything like SP0, SP1 or SP2 or SP3 or SP4. You just do SP5. So what does SP5 means? You have to travel through 5 vertices, right?
Yeah.
Yeah, the
In that
confusion, no, sir.
That's
SP3, we can travel 4 to 3 means we can travel, no? Because 4 and 3 is not there. But through via 0, 1, 2, we are using, no? So it
Yes,
is.
you can do.
Okay, sir. That.
You can do that, but you will not go via 4, 5.
4 or, yeah.
Okay, so now this is all about Floyd. Yeah.
Sir, what would be the value of SP6 matrix? Would it be a 0 matrix?
SP0?
SP6.
So if it is SP6, then you can travel through all those vertices like 0, 1, 2, 3, 4, 5.
Similar to SP5.
Like that. Did I understood what you were asking, or like you were asking something else? Quickly.
Okay. No, sir.
Okay. I understood then what you were telling. All right. So this is about Floyd-Warshall. I think, do you want me to explain Bellman-Ford, or you are very pro?
Sir, can you please go back to SP4?
SP4? Okay. It's here.
So if sir,
Is Bellman-Ford
here we are going from, sir.
You're going from
4 to 3.
4 to 3, suppose.
That's,
yes.
Which is 0. But if we change something that 4 to 2 is given 2, means it's different. Not that the smallest one we are just getting from 4 to 3, just direct edge, the 3 only, the smallest one. So
right.
we will gonna keep that 3 to 3, or we'll change that.
You mean to say from here 4 to 3, you're going 4 to 3 directly, right?
Yes, sir. And if you're going through using any other vertex, which is taking longer path, so we're gonna keep the direct edge, which is smaller, that same thing.
You have to
only,
choose
or
the
we're
value,
gonna...
not the edges. You don't count the edges, but you look at the values.
Okay. Okay, sir.
Okay. You don't count the edges.
Okay, sir.
You look at the values.
Okay,
Okay.
sir.
Yeah.
Thank you,
So
sir.
this is all. Yeah. So about Floyd-Warshall, this is all about Floyd-Warshall. Coming to Bellman-Ford, I think Deepak has discussed it. You can actually go through this, and you can actually go through this slide. It's actually explained it very nicely. If I explain you, this will take me half an hour to explain, and you have CT, so I think you should take a break for half an hour and then go for that. Yeah. So
What
actually,
about revision sessions?
Revision sessions is there. We will keep that revision sessions. So you can
Because
actually
it's not
practice
yet
this.
scheduled. It's not
No,
there in
it's
the
not yet
calendar.
scheduled. Yeah, it's not yet scheduled yet.
Before
I also
leaving, I
have a
want to
further.
ask a question.
Yes.
This infinite. Can you go back to the slide of Floyd-Warshall? Yeah. In this, I am really doubtful. How did you get infinity?
Okay, I'll tell you, because this is a very basic. This is like algorithm for this. From 3, you cannot go to
Are we
any other vertex.
initializing everything in infinity?
Right. So maybe I can show you the first SP0, then you will understand this. So what you do in Floyd-Warshall algorithm is, okay, so maybe you see here, if no path between the vertices, then simply the distance is what?
Infinity.
Yeah.
Simply
It's a part
before
of algorithm.
in CT, what we used to do is, if there is no path, we initialize it to 0.
Initialize to 0.
I mean, when we create a matrix, we initialize.
That is CT.
Yeah,
Okay.
we initialize
Okay.
everything.
Maybe like you can do, I don't know if you can do this.
No, but here.
Okay, maybe then I don't know what is happening
It's
with
okay.
the CT, or there
I
will be
think
some kind
there
of
is no
experiment.
vertex. You are putting it as
We are
infinity.
giving it as infinity. Yeah.
Infinity.
Sir, I have a request. Am I audible?
Yes, yes.
Last time when the mock was announced, we had the date that it would be, I think, on a Sunday, and it became live on a Saturday, all by surprise. And that was just a duration of 1 hour in which we had to do. And for example, I thought it would be for, say, a span of 2 hours, where we would have 1 hour to do on a Sunday between this time to this time, whatever was specified. So it took me by surprise, and I was not able to do that mock.
And even I missed.
So please, if the announcements could be done well in advance, and we could just
at least a 1 day
follow
in
that.
advance.
Yeah,
sure.
Because if we suffer, then the others, we don't have a timed mock, then we have to go with the untimed mock, which is not really the thing that we want.
Sure. We can do that.
So,
And about the
sir, I have a
end term
doubt.
exam, one second. About the end term exam, they are saying between 2 to 5 evening time. So each subject is going to get around duration of 1.5 hours.
Yeah.
Oh, that's good.
Yeah. So for your end term, for your mathematics, you will have 1.5 hours. So then you will have more number of questions. It won't be same as.
Yeah.
I'm
It
so
doesn't help to have 1.5 hours.
Ample amount of time.
Though you have time, but you have more questions.
Yeah.
Yes.
Right?
Sir, I have
So
a
if
doubt.
we have more time, we can think a lot. And we get those.
Yeah, sir, that is true.
Okay.
So could you please explain when 0 will come and when infinity? I'm very confused regarding that.
This Bellman-Ford?
Sir,
Sorry,
like, I'm not
Floyd-Warshall.
Yes,
For
sir.
Floyd-Warshall. So you see, if there is no distance, if there is no path to reach from that particular vertex to any other vertex, right? Or for, let's say, a vertex U has no path to reach vertex V, then you give U to V as infinity.
So if there's no cycle that is starting from one and ending at the same one, if there's no cycle, that's 0.
So if there is no cycle, let's say if there is no cycle, let's say from in the earlier example, let's say from 0, 1, 2, and from 0 you are not reachable to 3. Okay.
Yes, sir.
Then you give it infinity. Okay.
Okay.
Understood.
Yes, sir. So, like for the same vertex, like from 3 to 3, for example,
Huh.
If there's no cycle from 3 to back to 3, then it's infinite, right?
No, it is not like that. Can you think like
Yeah.
you are
Can we say it's
initializing
because
the
there is no
matrix with the
edge, no?
infinity sign? Because all the values are infinity, and if there is an edge, or if you can go with 2 or 3 vertices, then you will get some value. Otherwise, you will keep it as infinity only.
Can you come again?
If you are initialize with the infinity, like what we do in CT, the same way. Then if you can find the vertices, 1 or 2 vertices, through that vertices you can reach that point, then you can add the values and keep the value over there. Okay, if you are, while that adding time, if you are getting 0, then it is 0. Otherwise, it will not come 0.
And if there is no edge, you leave it as infinity.
Yeah, leave it aside. And here, the 3 from 3 there is no outgoing edge, so it is always from 3. No other outgoing, so it is always infinity only.
Yes, yes.
It is like that. Okay, if you are getting value 0, then only it is 0.
Okay, so if there's no outgoing, it's always infinity.
Yeah, if there is no outgoing, you cannot reach from other point, then it is infinity only.
Okay.
For example, yeah, you can see it here only. Sorry for interrupting. See, from 0 to 1, this is SP0. Okay. SP0 means you are basically initializing it. From 0 to 0, is there any path? There is no path. So infinity.
So there is.
See, where?
So 0 to 1, 1 to 4.
No. Look at this. This is SP0.
SP0
is,
yeah.
Yeah. This is not SP5. This is SP0. It indicates what? You are just simply giving, it's in simple way, you are actually giving adjacency matrix for this particular graph. So you first, you are just giving a path, you are entering the value for all those edges which has got a path length of 1, right? So 0 to 1 will be given a value 1, but from 0 to 0 in just one path, you are not coming here, right? You have to follow 4 paths.
The second one is not the special.
Sir, when you are saying adjacency matrix here, 0 to I got confused.
Okay, I'll tell you. You remember like how we find A1, A2, A3, A4 adjacency matrix? How do we get A1?
Yes.
Right.
A3,
so what does A1 indicates?
It's the first element.
It's an adjacency matrix with path length 1.
Yes, path length 1. Yes.
And when it is A2, then it is an adjacency matrix with path length 2, right? So when it is of 1, this is similar to this, like SP0. SP0 is like, you can think it as an adjacency
without
matrix.
any hope. She can think like at CT method. Direct edge and
so it's just one path,
only.
One path without, you are not going through any vertices. Okay. Right, so that way.
So just now, I think Dijkstra said that if there's no outgoing, it's infinity, but 0 has outgoing, and it's still infinity.
But SP1, SP0, no. So there is only one way, one outgoing edge that is going to 1. 0 to 1 only we can travel.
So
we cannot use.
Whenever it's SP0, all the vertices with itself.
Yeah, only edge. You should look at the edge. If the arrow mark is there, then only you can connect. You can write them.
Yes.
I'm asking if it's SP0.
In CT, it used to be 0. Here it is infinity.
Yeah, for SP0, 0 to 0, 1 to 1, all this will be infinity because.
Yeah, we cannot go.
Yeah. Okay.
Yeah.
So all right.
Thank you, sir.
Do you have any more?
Bellman Foods is also the same lines. In the same lines, it will be something.
No. It's slightly different.
Hello, sir.
Go through this slide.
We are keeping a route and traveling from that route to others.
Yeah.
Yes, sir. Can we discuss that graded assignment?
Yes, you asked me, right? Question number 3.
No,
No, sir. I asked.
Oh, you asked that, right?
I didn't ask before.
Yes, sir. Me, Rishabh.
Oh, Rishabh. So let me just open that. And those who want to leave can leave.
Thank you, sir.
Thank you.
It
Yeah.
was
thank
really
you.
helpful.
Yeah.
Thanks a lot.
Question number 3, that list
Thank you
one.
so much.
Question number 3 is that list one.
Okay. Somebody is telling something. Yes.
Sir, the document or the PDF that Shrikant sir and Deepak sir had used in the previous 2 sessions on graph theory, if those could be uploaded, I don't think they've been uploaded. At least
It's uploaded, I guess.
Yeah,
Yes, sir.
it is there.
Yes, sir.
It
It's
is
there.
I didn't find it. Could someone please share the link?
It is there in the resource from instructors. That part is there.
Okay. Okay. So somebody asked in the very beginning, like graded assignment question number 3, right?
Yes, sir. I asked Rishabh.
So week 11, right?
Yes, sir. Week 11. Question number 3. Graded.
Tell me. What is the thing you want?
I asked on the discourse as well.
Sir, can you open this? I mean,
I'll
yes,
share
sir. Yeah.
that screen. I'll share
Yes,
that.
sir.
I think it is regarding that list Q stack one, right?
No. Question number 3. Yes, sir.
This one? Oh, okay.
Yes,
Tell
sir.
me.
Yes. So here a square shows the distance 2, right?
All the matrix which contains and path length 2. Yeah.
Yes, sir. So, and sir, the next part of the question says the distance shortest path within any 2 vertices has length at most 2, right? So, sir, from the matrix we can see A, if we think like that, A, B, C, D.
Okay.
The column and the row we can think like that. A, B, C, D. Suppose the vertex name.
Okay.
So A, B, C, D. A to D. It's 0 in the matrix.
A to D is 0. Yes.
So, sir, but how it could be 0, sir? Because the question says has a maximum length at most 2.
Yeah. The shortest path between any 2 vertices has length.
Maybe it could be AD could be 1, right?
Yeah.
Yeah.
So 1 or 2. It's like that.
Yes, sir. So, okay, sir. But from the figure, every except the first one, other 3 graphs, every vertex has 2 shortest path and 1 also. I mean, I was a little confused how to choose from the options.
Okay. So all you can do here, Rishabh, is you can just start giving, you try to draw the graph for this and then match with this graph. Okay.
Okay.
Or
okay,
yeah, you can do that.
No, sir, actually the problem is here, sir, the figure in the graph, sir, the vertex is not named actually.
Yeah, I get it. Yeah. So what it is expected, yeah, actually this is creating a problem. I do understand.
Yes, sir.
But what you can do is you can actually draw with this. I mean, you can draw that edges. You can draw the graph for it with labeling it, and later on just remove the label and match with this, which among them.
Yeah, modify the graph according to the option.
Yeah, right. You can do that. Yes. Is there any more question? Do anyone?
Sir, I was asking the graded assignment 1. I got stuck there only.
Graded assignment 1.
Yeah, I mean, no. This graded assignment 11, question number 1.
Question number 1. Okay. Yeah.
Okay, I solved this question actually. I solved first for vertex by taking vertex 5, then 6, then 7. Then I actually generalized for the n vertices.
So you can try doing what he's telling, Rishabh, what Rishabh is telling.
Yeah, I did by at least 4 edges.
There was a voice overlap.
Rishabh, could you tell him? Rishabh, could you tell the banker?
Yeah, hello, am I audible?
Yes.
First, I did for 5 vertices by taking each vertex has at least 4 edges. Then I took 5 vertices, then 6, then 7, then 10, and then I generalized by taking n vertices and has at least 4 edges. And then I solved this question. Get it?
Yeah. I think what you are trying to say, I get it, but I took the same approach, but I was unable to solve it. I got stuck.
Okay. You simply post in the forum. I will try to explain there.
I don't have access to this course. Anyways, I can post it in Google.
So
okay.
Yeah, Divankash, like you can just try out. Like what he's telling is like something similar in the solution as well. So this is the way, like you just try to build that, so try to generalize and then
Yeah,
you will
try
get
to
it.
start from the basic, like the very beginning, and then keep it on in increasing. Sir, this question number 2, sir, how to draw the VFS tree? I was
VFS
actually stuck for question 2 and 3, else I solved all the question.
If G is connected undirected graph such that every vertex of degree has a degree 8, and how many? Okay, a connected undirected graph such that every vertex has a degree at most 8, and the shortest path between any two vertices has length at most 2. What is the maximum number of the vertices in G? Yeah. So
Yes,
what
sir.
you can first draw the graph and then do the BFS tree.
Okay. Okay.
Think it in that way. Yes.
Yes, I will try.
Yeah. All right.
Sir,
Sir, graded
I have a
assignment 10.
doubt in activity question.
Which activity?
Activity 11.3, question number 3.
Okay. So maybe after this we can end our session.
Sir, one more.
One more.
Sir, one
Sir,
question
actually,
I had, like in GA 10, question number 3, it was asked like which of the following structures could be used for a particular scenario, and there was list, queue, and stack, and another option, array. Right? The correct it was a MCQ, and the correct answer was like stack.
Yeah, it was stack. It was stack.
So I had chosen like stack and list both, because list basically is the base implementation for both stack and queue. You can use it like either stack or queue, and with the same efficiency. Stack will just have your additional, helpful methods. That's the only difference. If it was like a single answer question, one could choose stack. But it was like a multiple choice. So stack and list both actually could be
You
used for
chose
that
both.
purpose.
Okay. So
No,
maybe
sir,
like
actually
I would
two.
like
Question number 2.
question number 2. Okay.
Yes,
So,
same activity. Activity 11.3.
okay. So you want question number 2. So this one, right?
Yes, sir.
All you have to do is just do the the matrix multiplication for this one.
Yes, sir.
Do the matrix multiplication for this. First, this alpha and beta are 0, 0, right? Now after this is known, you do the matrix multiplication to only that row, which is where your alpha beta is there, right? And then you will get it.
Okay.
Yeah.
Sir,
And sir,
graded assignment 10.
Sorry?
11.6, question number 3, sir. Activity.
11.6, question number 3.
Yes, sir.
Tell me.
Yes, so this one.
Okay, so you see what is this? For what value affects the Bellman-Ford algorithm to find the shortest path from? So you see, whenever you apply a Bellman-Ford algorithm, you have to make sure that there is no negative cycle, right? You see, when will this not be a negative cycle?
Yes.
Tell me. When this x becomes 7, you see this is forming a cycle, right? 4 to 1. 4 to 1 is forming a cycle.
Yes, sir. 4 to 1,
So
yes.
for what value it becomes negative cycle?
-8. If x becomes -8, then it will form a negative cycle.
Negative cycle after 7, right? After 7, when you give it, let's say when you give it as -8, then what happens? 7 plus 3, 4 plus 3, 7 minus, so that gives you -1.
-1.
So
yes.
if x can even be minus, but x can be -7 because that is not a negative cycle, right?
Yes.
So the minimum after if you give it -7, or if you give it if you give x value lesser than -7, it creates a negative cycle, right?
Okay. Yes.
Yeah. So this way you can solve this.
Okay, sir.
We can.
Sir, graded assignment 10.
Graded assignment 10.
Yes, sir.
Sir,
okay, we'll
sorry
provide
to
that
interrupt.
solution for you. We'll provide. I have just messaged them. They'll upload it by today or like tomorrow early morning.
Sir, we
Okay.
can solve with instruction session slide. It is
We'll share
not
this.
good information orientation.
Sorry.
We can solve with instructor slides.
What happened with that?
Orientation is not in good.
orientation is not provided? I mean, what are you asking?
Not good orientation.
Landscape, sir, landscape.
Yeah.
Okay, the orientation is in landscape. Oh, I see. Okay, so let me see what we can do with that. Maybe we can try changing that orientation and we'll try to re-upload it.
Sir, I want to discuss one thing. Like in the quiz 2, we were asked the questions on log functions. So when we find the value of log with the normal calculator, I was able to do it. But when I used the TCS calculator, I was not able to use it. Like it was just showing the base value.
Oh, is it?
Yes, sir. Same thing I informed in the discourse also.
Okay, but
So sir, if you could help me, like if you can show me how to use it in the TCS calculator, that will be fine.
I don't
I'm
have
not sure
that.
if I was the only one not able to use it, or there
Is
was
there
a
anyone
problem.
else who is facing
No,
difficulty?
actually, I didn't get any kind of problem. I could solve all the log functions with the calculator that TCS has.
So just try it out.
Tried
I think
multiple times in that system, but it was not working for me.
okay, so maybe you can try it again. Like I don't know how to tell you like how to go about it, but try to enter it. You know, like I can't even tell you where to practice this.
Sir, it is available online. TCS calculator is available online.
So you can practice there, no? Yeah,
Okay, sir.
you can just give a practice there.
Sure.
Okay.
And sir,
Sure.
I have one more doubt. Like, can you please explain the difference between global minima, local minima, and the normal minima?
Okay. So do not get confused with this. Local minima. See, global minima is also a local minima. Understand this. Okay. When
But
we
sir,
ask,
for local minima, we have the condition like f double dash a has to be greater than 0.
So you see, there are some conditions. As I told you, like global minima can also be a local minima, not always, right? Because let's say if you have a boundary conditions, right? When the boundary comes in picture, right? So what happens is your boundary, let's say your boundary is the lowest value, then that becomes your global minima, right?
Yes.
But you can't do a double derivative test there, right? Because you cannot talk anything about derivative at the boundary, right?
Yes.
Yeah, so that point you have to keep it in your mind.
But sir, the normal condition, like for the local minima, it has been given like f double dash a has to be
Right.
greater than 0. And like in the activity questions also, few questions were there for local minima. Sorry, for global minima.
So
The
that is
value
like,
was more than 0. So like
okay,
I got confused in that.
you won't get it like that. See, when it is like local minima, then your f double derivative test will be greater than 0, local minima, right? But when we tell global minima, then and double derivative test is coming out to be 0, I mean lesser than I mean greater than 0, it indicates that it is this global minima falls under the category of local minima. Okay.
Okay, so it depends on the questions.
Yeah, it depends on the questions. But when the boundaries are given, make sure that you compute the values at the boundaries as well and get what is the value actually, right? So one is that at critical points you find out the values, and at the
If the boundary points are given, so first we have to find the value, like we have to do double derivative test or not?
not at the boundaries, but you will do at elsewhere. You will do at the critical points. Definitely you will do at the critical points.
Okay. And
Right.
And for finding the global maxima or global minima, we will simply put the value of the boundary points in the function, right?
Then what about the critical points?
For critical points, we will do the derivative test.
Yeah, you will do the same, right? So you'll follow the same procedure. You will have the critical points, then you find the values at the critical points, and also the value at the boundary points, and check which is giving you local maxima or like global maxima.
Okay, sir,
Okay.
can you please check this question, activity 9.2, question number 6?
Okay. (9.6) question number?
9.2, question number 6.
Okay, 9.2 question number 6. Okay, yeah, tell me about this.
Sir, here like the option is one is a local maximum. So it's a critical point. So for that, we will have to simply plug in the values, or we will have to do the derivative test.
Okay, so over here, you see there is a quadratic and a cubic equation, right? And
Yes.
for two different intervals. So what you have to do is you first have to, so first of all, this is a quadratic equation, and what you are asked to find in this option is local maxima, global minima, global maxima, and global minima. Okay, so what do you mean by global maxima? So that gives you the maximum value, right? That gives you the maximum value in that entire interval, right?
Yeah.
So which includes even the critical places as well, right?
Yes.
So now, what is your specific doubt here? What are you asking me?
Sir, like while I was solving, I did f of 1 equal to 6. I simply put the value 1 in the quadratic equation.
Okay.
But now I think like I had to
Differentiate that.
Yes.
Yeah, so you are thinking it right.
So I have to differentiate it, right?
Yeah. And then what
for
you'll
the
do?
yeah. So
Uh,
I will get the value for critical points
Okay.
for 0 and 1. And for the boundary points, which are 50 and minus 50, for that I will have to simply plug in the values, right?
So you see this, like you see this quadratic equation. When you find the first derivative, what do you get? You get minus 2x plus 2, right?
Yes.
And then you
Yes.
equate to 0, you find out that x is equals to 1.
1.
Right?
Yes.
And when you do the double derivative, what do you get?
Minus 2.
Minus 2. So what is that minus 2 indicates? It's a
Local maxima.
local maxima. And where is it happening? At 1.
Critical point.
At 1. At x equals to 1.
Yes.
Right? So that is given directly. 1 is a local maxima.
Okay.
That is definitely
Sorry,
right.
I just got confused.
Okay, no problem.
Thank
Okay, then
you.
we can end our session now. All
Yeah,
right.
thank
Thank
you
you,
so much,
everyone.
sir.
I have
Yes.
just one question. In
Yes.
graded assignment 11,
Uh-huh.
in question 13,
Okay, just a minute.
for example, we didn't solve with us, we got 6. So we said it's 6,000. So we added the zeros. So do we have to add the zeros because it's written in thousands? I'm assuming
Yes. You add them in. Add zeros.
we have to write 6,000 with the
Yes.
zeros.
Yes.
No, sir. Actually, we don't have to add zeros.
Why?
Because in the question,
thousands.
it's directly
Okay, it's
given.
asked in the thousands of rupees. So how
Yes,
many?
sir. We
thousands?
don't have
Yes,
to add
yes.
zero. Just
Yes. You don't have
just
to
the
add
value.
zero. Okay.
Sir, could you also please check your chat?
My chat. Okay, just a minute.
Yeah.
Final. Yes. Definitely, we'll do this.
Okay. Thank you, sir.
Okay. Yeah. All right. Okay, sure. We can do that. All right. All right then.
Sir, actually, I would like to add something. But sir, actually, I'm waiting for everyone to leave. Everyone, you can leave if you want.
Okay.
And
All right.
I think that the YouTube live has also been streaming going on, so it can also be ended.
Okay, maybe I can do that. I can ask them to. So basically, I don't do that. Somebody else does it. So maybe I can ask them. Yeah, but tell me what is it? Or you can text it here in. Like,
yeah. I can,
direct
yeah.
message.
Sorry. I can text you. Yeah, I can text
Yeah.
you actually. Yes, sir.
Okay. So meanwhile, like all of you, like you can join your CT now. It's 7, right?
Yes, sir. I've texted you, sir.
All right. I know this. This is some reality, you know.
Yeah, I mean, is it for like intentionally or by mistake? I was confirming.
It's those who are smart, you know, they get it.
Yeah, actually, I checked all the things. So before
Yeah.
joining today I saw the graded assignment for week 11.
Yeah,
So
yeah,
I
right.
checked all the things, the peer deck activity also. I
Yeah,
already
yeah.
did in the morning,
Right.
and I
Right.
watch all the things.
You see, week 1 to 4 are very unique. Okay.
Yes,
You will
sir,
not
yes.
find it. Yes. And that is very much essential for your qualifier point of view. After that, it's not essential. Right?
Yes.
It's up to you, like if you want to cheat and give the answer or like however. So actually what you're telling is right, but you know, like we actually discussed this, like what can be done about it, but we did not get they were like, it's okay, let it be. So
Okay.
even we
Okay.
got it right. Yeah. So that's okay, no problem.
Okay,
sir. That's fine.
Okay. All right,
Yes,
then.
sir.
Thank you.
Yes, sir. One more thing, sir.
Yeah, Rishabh.
From Big 12, the lecture one lecture I watched, a revision lecture on graph and graph theory basics, where Rahul sir and one more, I think, Deep Jyoti Viswas sir, I think.
Okay, Dev Jyoti, huh?
Yeah, they were like discussing. I think sir they discussed in a very good way, and where Rahul sir has performed the role of the student, like any doubt or something, that was great.
Okay, nice.
Whatever doubt actually we can think,
Yeah.
he actually did in the same way.
Yeah, right. So that was the whole intention for creating that kind of thing, you know, like to have ask
sir,
all
just,
possible doubts. Yeah.
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 Thank you so much, sir.
Yeah, you're welcome.
Thank you.
All right, then. Yes, we may leave now. We can close our session.
Thank you very much, sir.
Thank you. Yes, thank you.
Hello. Hello. You guys have only registered for maths.